purchased by Attachmate, which was purchased by Micro Focus. Then SUSE was also purchased by what is now the owner of the company, which is EQT, which is it's a private equity firm. And then it was brought out on the market and it went public on the Frankfurt Exchange and then was later bought back by that same company. So you can tell it's been some ups and downs with SUSE, so therefore like the community always has a little bit of anxiety about how it moves. So that was sort of the background of, well, ultimately the foundation becoming a thing. And what does it do, right? So it does enable some financial benefit for the community. And it was always difficult because if you are familiar with some of these projects that have been established by companies, there's a difficulty with it because funds would go up, and the way companies work is like that doesn't really trickle down to like the community efforts that we have in open source where they're participating in. And so that those funds don't necessarily trickle down to the people who are contributing. So it did give at least an area where we could primarily focus funds or capture funds for the community to their benefit. And then the other stuff is just sort of the background on what the other technical things are that we have for the project or for the foundation, why it was established, and the things that we support. So here are some of the things we've been involved with in collecting funds, and this or activities where we're out primarily advocating or marketing for the OpenSUSE project or the Geeko Foundation in general, as well as other open source projects. But OpenSUSE has been established as a mentoring organization for the Google Summer of Code. So it allows for us to support that where we would actually take in the funds and then use those funds to help out the community or the mentors in a sense. Of course, the OpenSUSE conference, we've sponsored that, the OpenSUSE Asia Summit. We've been at these events where we've raised funds for the community. If you were at FOSDEM and you wanted a beer, you could get one and maybe some funds end up in the hands of the community. So anyway, yeah, primarily that's what we're doing right now is raising funds. Developments that we have taking place, you noticed on the last slide we had gone to Scale, Patrick had gone to Scale, and that's a Southern California Linux Expo. And so anyway, like there he talked with a few other distributions, communities. And the one thing about open source is, right, we all kind of work together, and it is an established community in general. I mean, we have our differences, but like primarily we all work on the same things and we collaborate. So it's important that we wanted to chat with them and let them know what we were doing. Also invite them to participate in Geekos, and those discussions have actually flourished into morphed into other things, which you'll probably hear more about it at the OpenSUSE conference. So the establishment, we'd want to start a 501c3 in the US is what we're aiming toward, but it probably it's called something different, right? And then also looking at establishing a foundation in Europe because the Geeko Foundation was established in the UK, and so we need a European entity or EU entity. So where the funds come from, right? So a couple days ago, I just basically did the balance. It's held in British pounds, we'll say, but the finance that we're using is broken up into pounds, euro, US, and USD. Again, where we collect funds or actually like receive funds and donations, we could do it online. The logo, the use of the logo. So if you go to shop.opensuse.org, you'll see a variety of different companies. Freeware, for example, they donate a certain amount of sales that they have. And so that just happened this last week. So that those numbers I just showed you actually bumped up. Spreadshirt's another one. So every sale, there's a certain amount. And the thing was, before the foundation was established, these funds would just sit there you'd see it grow, but you couldn't do anything with it. It wouldn't go anywhere. So at least with that, we are allowed to capture that and put it to good use. Mentoring is another thing. So Google Summer of Code, there is I believe it's $500 per student that the mentoring organization receives in funds. And so this year we have 11, so that gives us quite a bit of funds to actually send people who are mentoring to the Google Summer of Code summit that they do on Google's campus. And so last year we had 8 and we sent to 2 people. And this year, this year we are also kind of like planning for 2-ish, if that'll work. Some of the main sponsors, right? So we have ARM, we have SUSE, which I guess I have a typo there. I was gonna bring a little plushie and hand it out to someone who found the typo, but it should be lowercase a. There is. Maybe go out and get your prize. So yeah, freeware again, Spreadshirt. We're looking to expand that, and if we'd like some other companies to come on board. I had some conversations a couple weeks ago with HPE. So, if someone's sponsoring the OpenSUSE conference, it allows us to actually take in those funds and get them out to community, right? So, next one, travel support program. So this is what we've done so far. We've taken over the travel support program for SUSE, and we have expressed the interest to Fedora and CentOS actually, if they want to do this. But at this point, they're kind of like waiting for developments to take place. And it probably again will be under something else, but we probably could still use the same infrastructure and collaborate as a team. So we submitted a proposal to SUSE. They are donating a certain amount, and then we're allowed to go ahead and use those funds for supporting people who are coming to conferences and giving talks. I'm not using that. I'm doing my own funds here and doing this on my own budget. So, but other people can use this for various things. And you can see last year, we started it off, actually that was where we captured, officially captured the TSP would have been like late last year. And so we used a little bit in the beginning. And then there's also some other funds that were for the Google Summer of Code, but I didn't count that in those. So where we're at right now, we had a few that had gone to FOSDEM, as well as Chemnitz Linux Talk. And then currently we have about 10,400 pending that would be going to future events. And having gone through this, we're sort of reevaluating perhaps like what sort of limitations we might need to have on the travel support program, because previously, and I had run it before, we never had that amount of people interested in using the TSP. And so now those numbers have almost doubled. And so we're kind of going to have to look at how we're going to support that with people submitting for travel. Right now it's like can provide up to 80% of travel. And but you get into variance because you have different people have different habits, behaviors, a few other things, and so they might decide to stay in a hotel that probably they could stay in another hotel and save money. And so we're going to evaluate that and see what we can do. So future plans, we're looking at having a workshop or meetup at the OpenSUSE conference. This is to kind of look at the governance model. We're also looking at going to CLUC to Fedora to also discuss very similar things, because we're wanting to, again, communicate with our other distributions that are out there and make them aware, and also like see how we can make the governance model work together. And then, yeah, we might create a new event in the future. I don't know. The OpenSUSE conference this year, we have some talks that will probably discuss branding. As you might notice, the Geeko Foundation does have a different logo than last year. Last year it used to be like an eye looking up at a star, where this is, we kind of have taken the winner of the OpenSUSE contest, logo contest, and then we've incorporated into this. And that is to perhaps give a good easing should some things come at the OpenSUSE conference, where we're looking at possibly a name change or a logo or something like that, logo change. So in summary, we are progressing. It is going a bit slower, but we are getting there. We need more people to assist, so we also need to like establish a few more communication channels. So we're looking at possibly like having a mailing list for this. Again, this is also one of those aspects of like informing the community so that people are aware what we're doing, how the community is benefiting, because I've seen that in email threads where it's like, well, what are you guys doing? It's like, well, you know, this is kind of supporting that, but again, the community wanted it. Now it's sort of like how you get involved, and we have not had much of a discussion on that from other people. They're waiting for us to do something versus like adding support and being a part of the solution here. So again, we need more people, we need more input. And that's my slide. I put the donations up there. So the first ones are from Stripe. We have incorporated wallets for crypto to include, well, Bitcoin, Solana, and Ethereum. If you want to send a stable coin or something like that, we're still figuring out how that's going to work as far as the accounting goes, but we don't want to limit receiving funds. So, and if you have any questions, please go ahead and ask away.
Awesome. Why do we need the microphone?
I think it's people online.
There are people online, okay. Great stuff. I'm so happy that you're working together with Fedora. They have a really great travel program as well. So is the intention to have a unique, you said, governance model for, you know, supporting everyone in the open source community for if they need assistance for travel? Depending on your answer, I might have some more ideas.
Yeah, so we have, by the way, we're having meetings, the trustees, we're having meetings, and one of those is sort of like, it's like we wait on funds until funds become available. Like, should you say, I don't know, should someone go, I want to use the OpenSUSE travel support program, or sorry, the Geeko travel support program to go to, I don't know, let's say a Solana blockchain thing that has really nothing to do with perhaps the Geeko Foundation. I mean, that would come down to a discussion. And I don't think that would be something we would support. But again, I'm just one voice. And so I would have to talk to the other trustees and also see what the feedback is. So, but yeah, let's say you want to go to something that would affect our environment. I think that, yeah, that would be acceptable.
Yeah, thank you. And my question was actually about, do you expect Fedora as community to contribute to the Geeko Foundation money so we can join the efforts of sending more people to different events based on the rules? So
actually, that is kind of one of the reasons why it was established. So we had a situation last year where the TSP was under the OpenSUSE project, and we had a person coming from Red Hat to go to the OpenSUSE conference to give a talk, and they were going to use the travel support program. And then they were informed that that is not a good idea to not do that because you can't accept funds from a competitor, in this case, right, like, because SUSE kind of was supporting that, but like it was clearly being done through their financial departments or whatever. And so that was specifically established for those situations because we do have cross collaboration. If you are working on some project where there's, you know, we call it DNF or something like that, like, yeah, we want the maintainer or the person who's actually in charge of that to come and give a talk. And the fact that they might be working for another company doesn't really, shouldn't be an inhibitor. It shouldn't be a problem, right? But yeah, so it would, in that situation, yes, we would support that.
Thank you. And I found another error, so where's my prize?
You're gonna have to talk to Patrick.
All right.
but just go
Thank
out
you.
to the
Thank you.
go out to the booth, and you know we have a few things there. We have some T-shirts, and of course there's stickers and other information, but we also have plushies as well. So no what? Yes, no install. No, sorry. I don't know if people would trust that. You know, I mean, some people. Yeah. Any other questions? You had a question, right?
Hi, thanks. Is Geeko Foundation planning also to have a legal or policy activities related to free and open source software?
We do have legal representation, but I would say at this point we're not there. We do have, I mean, right now we have the trustees. We have some establishment with like insurances for the trustees and things of that nature. There is support that Patrick is in he has lawyers looking at the things that we're going over. But at this point, no. I mean, it's three of us and we're doing it in our limited time. So, does that answer the question? Okay. But we would love for FSFE to somehow, you know, maybe lend some support and we could do something similar. Any other questions? All right. Well, thank you very much. I appreciate it. And stop by the booth.
And now, please welcome Ms. Niharika.
And now? Perfect. Okay, so I'll begin from the start. Thank you so much for having me here. My name is Niharika, and I work at the Free Software Foundation Europe. And today I'm also going to be speaking in the capacity of a consortium member of the Zoom project. So this project is basically funded by the European Commission, and it aims to basically provide tools, provide guidance to companies, startups, software developers who basically want to license their business model based on the 3 O's, so open hardware, open data, and open source software. So yeah, today's talk is going to be all about the concerning problem of proliferation of AI licenses with additional behavior restrictions, which are based on ethical considerations. So if I'm talking about openness and ethics as a concept, I want to first begin with enunciating how openness is subsumed into the definitions of free software and open source software. And yeah, I'm pretty sure this brilliant crowd out here already knows about the differences between free software and open source software. But since everything is based in definitions, and I want to highlight as to how important it is to keep in mind the definitions or the strict definitions provided by free software and open source software, which are regulated by Free Software Foundation and Open Source Initiative, respectively. I want to highlight how these definitions actually have an impact onto the AI licensing landscape today. So as you see, free software actually provides you with 4 freedoms. That is freedom to study, use, share, and improve. And open source software is regulated, the term is regulated by OSI. And this basically tells you that open source does not only mean access to the source code, but also asks you to comply with these conditions. Yeah, so there are multiple reasons to engage with free software. While proprietary licenses are fundamentally incompatible with each other, free software licenses, on the other hand, are well standardized, well documented, and have actually withstood the test of time and complex legal issues that it's witnessed in the past. And so what it does is that it seeks to curtail the problem of licensing proliferation, or in today's current landscape, the problem of AI licenses proliferation. And it seeks to enhance the legal interoperability and thus make license adoption easier. So as you see, the free and open source movement has actually had a profound effect onto software development in the last decade. Earlier, proprietary systems just restricted access for the users, they locked in the users, and that basically stagnated innovation. But free software licenses, on the other hand, opened the code, and they provided access to the users, and so it basically enhanced or accelerated the innovation. And why I'm talking about this is because if we juxtapose this to the concept of ethics, then I would rightly state that the free software movement in itself is an ethical movement, which has basically contributed to digital justice, social justice, reciprocity, altruism, promotion of digital goods or digital commons, and yeah, you name it. And that's great news because free software powers much of the internet's infrastructure, including key machine learning frameworks and various libraries and projects like Linux, Kubernetes, PyTorch, etc. And it also constitutes an integral and an indispensable part of AI research and development. So safe to say that free software actually provides more fairness, or it actually aids in more fairness or transparency or accessibility to the AI systems. But AI systems don't really operate like traditional software. They have multiple interconnected components like training data, model architecture, algorithms, tokenizers, etc. And they require distinct development processes that rely on specialized resources, mostly available in the hands of big tech. So although the ideology of free software is mapped in the concept of OpenAI, we must be really careful because these are two different concepts. These are two fundamentally different areas, simply owing to the fact as to how they're built. So there's a lot of components at play here. Sometimes the code around the model, the code around the weights would be open source, and the model might not be. And so what is particularly concerning is the growing trend of these publicly available models claiming themselves to be open. Many of them rely on the term open, which basically broadly means to provide some sort of minimal transparency and reusability. But in reality, they're actually not using any free software licenses. And so if you're using the definition free software and open source software, then we must not forget the key pillars that actually make them free and open. And those are transparency, reusability, oversight, and enablement. So transparency in the context of AI systems would mean the ability to access and vet the source code. Reusability is to make a third party, make the source code available to a third party in order to rebuild the algorithms. Enablement is just to disclose sufficient information to enable any third party to build a model, provided that they have necessary computational resources as identified by the community. And oversight is the ability to just inspect and verify the source code by anyone, which also helps to minimize any discriminatory effects on the AI systems. So now, as you know, OpenAI is actually a very incumbent concept, and that's because of certain reasons. One, currently we do not have a robust definition for AI systems, and another one for what openness in AI systems would mean. But that's going to probably come to a halt with the enforcement of the AI Act. But as regards the definition of openness in AI is concerned, I would actually take a moment here to applaud OSI, which has taken a great initiative to actually come up with a robust definition for OpenAI, which not only includes the traditional four freedoms provided by free software, that is the freedom to study, use, share, and improve, but it also takes into account a wide spectrum of AI technologies. And it's my utmost pleasure to announce that leading partners of the Zoom project that I've been associated with are also helping and aiding towards this initiative. So yeah, until we have a robust definition for what openness in AI actually looks like, anything labeled as open AI actually exists on a long gradient. And there's this really interesting, sorry, I think the slides are a bit messed up because of the change in format, but I have another version available, which would also make the source clearly available. So this interesting paper by Dr. Vidya actually provides you a lot of insight into it for anybody who's interested in deep diving into the subject. But yeah, what this basically means is that there is a long gradient on which the OpenAI actually exists. And on one end of this gradient is you'll find these maximally open AI systems. And on the other end, you'll find AI efforts like Llama 2, or now Llama 3, as recently released in April, so last month. So, and now, if just talking about these AI licenses with least transparency, so for example, Llama 2, this claims itself to be free and open, but actually levies a lot of restrictions onto the users and provides minimal transparency to the users. And it also has clauses like, if the user base actually exceeds a certain number, then they require a special license by Meta. So as you see, by default, it's not adhering to the standards that free software and open source software has live up to. So what openness in AI really looks like in practice varies considerably from making the training and evaluation data sets publicly available to making the model weights publicly available or documentation around the AI, such as the model cards or data sheets publicly available. Therefore, given the lack of any definition on what openness in AI actually means, any legitimate claim to OpenAI must rest onto the curated definitions of free software and open source software, because these actually carry a rich history of over 40 years of democratizing control over software. Now, in the last decade, we've had few groups and individuals who've departed from exclusively using free software to creating their own licensing schemes, which basically impose behavioral restrictions related to field of endeavor, behavior, community management, commercial practice, and ethical incompatibility. In 2021, OES released the Hippocratic license, which basically prohibits the use of open source in violation of the Universal Code for Human Rights. And this practice has now spilled over to creation of suo motu ethics codes on AI systems, which basically leads to creation of licenses with restrictive and prohibitory licensing schemes in nature. And I've already given an example of Llama 2. So here we are with an entire appendix which contains prohibitory uses. And well, they just didn't stop there, because now we have Llama 3, which released last month, and it also has the same clauses. So and the same practice is carried on by Big Science OpenRail M license as well. As you can see, there are a bunch of restrictive licensing clauses, license clauses here as well. So what are the implications of use of these licenses with additional behavioral restrictions? So the first is barriers against use and reuse. Now, as you see, and I will just I would just go back to my previous slides, all these licensing terms and conditions are extremely vague and ambiguous. And what happens as a result of this is that it creates a broad prohibition on its use, or on the use of AI systems, and this has a cascading downstream effect on the integrity and availability of AI systems. So in general, it actually hinders any global collaboration. Then hurdles to adaption or improvement. This is by way of prohibiting copyleft or share-like clauses, or by unauthorizing derivative works. And hindrances to control over technology. So if we have proprietary licenses, essentially we're just relying on the licensors or onto the vendors, and they block the access to the AI systems by way of strict API control. And so the users do not have control over the technology. And weakening external oversight and transparency. So although a proprietary license or a proprietary AI model could also be transparent, free software transparency helps in auditing the source code. It provides the condition that any user can access and verify the source code. So now, since we have a lot of AI models flooding the market, there's also this enhanced requirement of having numerous standard risk assessment tests or model evaluation tests. And with using free software, it just makes compliance much easier. So in conclusion to our contribution to the Zoom project, we've come up with certain conclusions or certain recommendations. So first is to preserve the openness in AI. Then we acknowledge that in the near future, we might have new and dedicated AI licenses, which is a natural progression to the free software licenses that we have, and this is a much desired phenomenon. We only plead that these licenses must be interoperable with the existing free software licenses in order to maintain the legal interoperability between different software and AI models, and just to make the AI systems more accessible, reusable, and sustainable. Then talking about ethical compliance. So since this is the crux of the subject that I'm talking about, ethics as a subject is deeply rooted in societal values that differ from one jurisdiction to another. And problems of accessibility, transparency, explainability, interpretability, all these problems actually make the deployment of AI systems ethically challenging. Therefore, we need to carefully embed ethics into AI systems or technologies in general. Now, there have been a lot of initiatives taken by AI researchers and developers, and those relate to, say, creating tools for auditing the AI models regarding their fairness, explainability, and robustness. And we also have things like creating these standard risk assessment frameworks for evaluating the risk of open foundation models, say. And we also have now establishment of ethics review board in different AI research labs, etc. So for example, Meta has its own oversight board, Microsoft has Aether, Google DeepMind has Responsibility and Security Council. So as you see, there are multiple ways to make AI systems more ethical, but placing any restrictive conditions on the AI model by way of a license and claiming to be open and free is actually an antithesis of being ethically compliant. So, there's also this problem of people or in general organizations now wanting to be labeled as, or labeling their products as more open and free. And it's not really required. I mean, sometimes the law also, wants that the model should not be open per se. So there is no straitjacket requirement to be open, but should you be calling yourself as open and free, then you must respect the definitions of free software and open source software, respectively, because these have set a standard for over 40 years. And by placing any restrictive terms and conditions to the licenses that are being popular right now, it's basically denuding the standards that they've placed onto the market. And so your legal department will forever be, inundated with a lot of complex cases because of lack of any interoperability. So bottom line, what I want to convey is that any placement of restrictive terms and conditions should rather be under the purview of regulations and law, and not by way of licensing schemes, because licenses are not a substitute for good governance, and licenses cannot be a substitute for regulation. So yeah, with that, I'd like to wrap up. Thank you very much, and I hope this was insightful for you. If you have any questions, I'm here to answer them.
So a quick question. So licensing primarily is based on the copyright, right? So it's the exceptions to the copyright what you are allowed to do. But we have seen that one of the big pushes in the AI space is towards safety, implementing some rules which prohibit you from doing something, which seems to be contrary to the free software principles, that there is a source and you can change it and you can make it do what you want. So what I'm afraid is that the legislation itself might prevent the software from becoming fully free, because yeah, here's the software, but you are not allowed to change it. Like we have, like, for example, in the wireless industry, right? You're restricted from changing the frequencies because the law says, okay, this country may use these frequencies, this country may use these frequencies, but you're prohibited to do that. So even if you wanted to do the open source, you are basically prohibited by law. So do you have any view on that and how can it be solved?
So say, even this movement is compatible with the laws. So when we talk about the free and open source movement, we're not essentially saying that we're going against the laws. But when we're talking about placing these restrictions, as now it's emanating from different regulations across the board, ranging from the AI Act now, and it also has certain restrictive clauses, yeah. So, but when we're talking about, say, security and safety, as you mentioned, that, those prohibitions mostly skirt around these issues, that the AI system should be not ethical, but rather should comply with the safety standards or, security standards. But this is a regulated space. So there were prohibitions even before, because it's a regulated space. Now with the AI Act, it's also stating the same. Since it's a regulated space, and it probably might also have a high-risk impact or whatever, as mentioned in the appendix, etc. There would be an accompanying, I would say, sort of, how's the word? This must be sort of accompanied with a set of practices that basically check that you're not, that you are actually abiding by those standards. So for example, under the AI Act, you would be required to carry out certain compliance checks. So for example, having certifications in place, having codes of conduct in place, but those are mandated. Those were anyway mandated because it falls in a regulated space. And there are also exceptions now for anybody wanting to use free software in the AI space as well. So, there are exceptions, but since it's also a regulated industry, we have to follow the standards set by it. And the upcoming regulations are only validating it, but they're not asking you to sort of, have ethical compliance checks by virtue of having restrictive licensing practices. So we're trying to also set apart these licensing, restrictive and prohibitory licensing clauses from the regulatory mandate, which is to actually have, certain certifications and codes of conduct. So what I'm also trying to exhibit here is that perhaps the intent of Meta by virtue of Llama 2, etc., would be nice. It would be to, promote this ethical, the ethics of AI, or the responsible, the AI should be responsible or more, secure. So the initiative might be good, but what I'm trying to point out here is that the application isn't. So essentially, even with the free software movement, there are exceptions now in the AI Act, but it is what it is. If it's a regulated space, if it's posing some sort of high risk, then if the law demands you to have certain checks in place, then you got to follow them.
Yeah, but that shouldn't be, your point is, as I understand it, it should be done by the copyright law and licensing, but the separate AI safety laws or whatever.
Exactly. So my point is exactly this, that it shouldn't be by way of this suo motu creation, or like creation of restrictive licenses by the vendors themselves. It should be something that is authorized by the law, and the law gives you certain certain practices, or it gives you this leeway of, or not leeway, but rather provides you with certain checks and compliance checks by having these certifications, which are uniform across the world. So you look at these standards developed by leading standard developing organizations. So those are the standards that one can comply with in order to make the AI systems more responsible, ethical, you name it, but not by virtue of creating these suo motu ethical licenses.
Thank you.
Is any license legal? I mean, if somebody invents some kind of software, is he allowed to invent also any type of license, and law must abide to what he thinks or says should be done about the software? And I would also ask is it possible that something that was up to now legal becomes illegal from now on? For example, if some license makes too much problems, is it possible that laws has say this license is illegal and you must not apply it anymore?
So you see, these licenses that I've just mentioned, they just, okay, I will also get back to this, but so these licenses are actually proprietary in nature, is what I'm trying to say. They're not free and open source. And so there's actually, I wouldn't say that, you know, here we're contesting about the legality of the license as such. Because you can use a proprietary license, yeah? You can have a license in place and place it onto your AI systems or any technology, regulating its use and distribution. That's fine, but that's a proprietary license. It's not free and open source. And free and open source has a certain connotation to it, it has a definition, so it has a certain connotation to it, which means that the AI system or the technology, the software in question you should be able to freely distribute it, provided that you're following the terms and conditions on the license, and you're able to allow anybody to freely use, study, share, and improve. But if you have certain licenses like these that I've just pointed out, these are just proprietary licenses. Calling themselves as open and free perhaps might be incorrect. It's also misleading. But as such in its existence, I wouldn't say that they're illegal. You can still use a proprietary license and license your software as how you want to. But if you're just using the terms free and open source, you're misleading. It's a misnomer, and you're misleading the community into believing that it's actually providing you with all these freedoms. So now somebody who's used these licenses, thinking that it's free and open source, will now combine it with some other license. And then what you have as a result of this is a complete mess.
Okay, thanks.
So I've also mentioned the policy brief and the project that we're working on here. Feel free to scan it and have a look at the website because it's got a lot of interesting content. It has, somebody has a question. So it has certain documents and policy brief that we presented to the Commission.
Hi. So how do, in my opinion, I'm a layman here, but in my opinion, there should be no free license if the training code and training data is not a free also. But turns out that most of those models were trained by using copyrighted data. So what is your thought about how this license could reconcile the fact that nobody can open the training data and the training model, not just in inference step, but making the data, keep the data copyrighted? I think that's the biggest hurdle in making the completely fully free AI.
So can you tell me the main point that you want to sort of
so how
get an
to
agreement
create a license that is completely free and have the model and the training data free, but we know that training data is copyrighted.
Mm-hmm. So that's the thing, as I mentioned, these licenses, the traditional free and open source licenses, are only, so they're very traditional and they apply to software. Now, since we're also applying it to AI systems, one needs to take into consideration a lot of things, like there's this data here, there's the code, then there's this hardware, etc. So it's a mix of a lot of components at play here. And then there are copyright issues concerning the database, etc., and that's a separate story. But there is no one license, a wholesome, robust license for the entire AI system. And so, which is why I mentioned that in the future, we might have a dedicated AI license, which takes into account all these aspects about what you mentioned regarding, say, the inference code, the training data, etc. But right now, we only have few pieces here and there out of the traditional licenses that we have that cover the AI system. so the software in question. Then we have the database rights under in the EU law for the training code, etc. So it's a mix of a lot of things here. It's an interplay between different components. And so I wouldn't say that, there is one license here which can solve all your problems, but in the future, perhaps there might be. But until then, if you're using a certain license, then all I'm trying to tell here is that you must respect the definition that it carries, because this problem just leads to a lot of legal interoperability issues. And not only in terms of, say, software, but also these ancillary problems involved.
Thank you. And perhaps just to refer to your presentation and also to your question, I think OSI is defining what elements should be into the definition in order to consider an AI system completely open. So yeah, when they have the definition, perhaps we'll be able to define which elements we need in order to AI system to be defined as open.
Yeah, right. So again, the initiative by OSI is to define the contours of open AI. But if you're asking about any such license, any dedicated license available on the market for AI systems in general, in order to license the entire system, then perhaps you have to wait for new dedicated AI licenses.
Any more questions? Okay. Thank you for your presentation.
Thank you.
And now we have the lunch break for 65 minutes, and then we will see you back here.
Sorry, there has been a slight mishap. This is track 2. So anyone who's looking for the postgrad lecture should be going to the track 1. Thank you.
Hello, everyone. Thank you for waiting. I apologize for the 5 minutes we took. The time will be compensated. Now, please welcome to the stage Mr. Theodore.
Thank you, everyone. Yeah, so, hello, I'm Theodor. You can call me Theo. I'm from the Polytechnic University of Bucharest, and I'd like to talk to you about what we've been doing on related to education, namely what we call the Open Education Hub. It's a project by which we want to make life easier for teachers as well as students. So, in general, teachers like to see themselves mostly like this, engaging with the audience, like I'm trying to do now. But more often than not, they turn to doing this, which is a lot of paperwork, a lot of bureaucratic and administrative stuff. So there's a heavy discrepancy between these two, which is what I'm trying to highlight here. On a similar note, many teachers would like to be mentors more than, let's say, task fulfillers. So to summarize all these, we believe that teaching is mostly about mentoring and getting a personal connection with the students, because from a certain age onwards, at least, education can't really be done en masse. You need a more individualized approach to cater to everyone's needs. And this is where mentoring and personalized training comes into play. In addition, in order to have a good relationship with students, there's this feedback loop that we're trying to implement, where we evaluate periodically, then we send recommendations to students so that they can continue to develop gradually and not just have one final exam where it's all or nothing. And of course, we'll discuss today about how we try to make our content as highly qualitative as we can. So the reality is most often that teachers are engaged in a lot of administrative work, too many papers to grade, too many activities to take into account, which can be automated most of the time, thus leaving teachers with more room to discuss with students and to do more meaningful connections like one-on-ones. So as another summary of what I was telling you here, we're trying to move away from the mundane tasks of teaching and stick to what we think matters. And the most important thing out of all these is going to be automation. There will be another talk towards the end of this day that will be also be delivered by a teaching assistant from our university, and that will focus more heavily on automation. Now we'll discuss kind of the structure that we are adopting, as well as our methodology. So we are called the Open Education Hub. We want to aggregate multiple courses in an online manner that's very simple to contribute to, that's easy to replicate and to distribute, so that we remove as much of the burden from teachers as we can while still keeping things available for students. Thanks. Which is what it has been condensed into this kind of mission statement that we've stated here. We started this project as a European grant, which was taken in association with the University of Iceland, and they've been our partners. We've developed courses together, and we're working together with them. They've been like great partners in this, and together we've come to model our courses on the OER model. This is based on the 5 R's, as they are called, mainly retain, reuse, revise, remix, and redistribute. What these mean is that first, when we retain something, you mean that you store a copy of your content locally, and then you can reuse it, meaning that you can have multiple copies in multiple places, and they can even differ from one another, which is where revise comes into play, because it's easy to make contributions to these pieces of content. It's very easy to amend them and to create even standalone replicas that differ from one place to another. Remixing is where we bring these contributions into the same mainline repository. And then redistribution is, if you think about it, it's the end of the loop where we send this content to make it available to students and to other professors as well. So what we had in mind when we first designed this methodology is that a lecture, a presentation, would have the teacher come into the class, and then everything, all the materials would already be available online for students to engage with prior to the lecture, during the lecture, or after the lecture. And then the class shouldn't be about the teacher trying to remember where all the materials were or how he was supposed to do things, looking for them. If they're already available, then there's a lot more time to engage with the audience, ask questions, answer questions, and provide assessment via, for example, quizzes. There can be pop quizzes during classes in which teachers can very quickly assess whether something has been understood or not. Same thing goes for the practice sessions. These are the more drill-like or task-oriented things, like lab sessions, where the first two steps are the same. So we want to keep our materials present online in a continuous form so that no one ever has to wonder, hey, where's this lab? Where's this material? Where can I find information on this? And then we aim to provide students with a pre-made development setup, such as a virtual machine or a Docker container, so that they don't have to worry about the setup so much, because this also takes time and takes energy from the teachers to help with debugging, installation, which is not necessarily fun. And once again, automation is our way of doing things. Assignments follow the same principle. So the assignment is already stated. All the necessary code and instructions are there in place, usually in a repository or accessible online. And then we like to have the ability to tailor assignments to each student's needs and maybe differentiate a little bit between what each student gets, so that they don't feel like they're doing the same thing, all of them doing the same thing with no personalization. And if you've been looking at these, let's call them steps, the teacher only comes towards the end and provides human interaction, human feedback, and anything that can be done automatically, such as grading, and providing static machine-like feedback, like, hey, your code isn't formatted correctly, or your code doesn't apply some linting specifications. This can and should be done automatically, and the finer things are down to the teacher, which is how we came to our vision. That, and this is in relation to the OER, the 5 R's of OER. Meaning that we maintain a central repository under the Open Education Hub organization in GitHub. Then each teaching institution, for example, our university, will create a fork of that repository, add changes to that fork, then push those changes upstream to the central Open Education Hub repository, where they will be stored in a, let's say, global manner, and then each institution is free to choose whatever content they wish from that central storage, so that they can personalize their content however they wish. And I'll show you this with regards to our structure. And also be able to curate and maintain things in a slightly more organized manner, as opposed to every institution having their own independent piece of content. So what's important to take from these things is that if you want to use repositories, you should be able to make your content as textual as you can, which is easy for code, not necessarily easy for presentations. meaning that most of lectures are delivered using PDF slides or PowerPoint slides. These aren't particularly good to be hosted in repositories because they're binary files, which is why we propose to use Markdown for most of these things. Assignments and anything that's written and meant to be consumed as like a book is very easily written in Markdown. The main issue here were slides, but as you can see here, you can make slides using Markdown. For instance, these slides that I'm presenting here are made and rendered using something that's called Reveal MD, Reveal Markdown, which is nothing but a tool that will convert Markdown slides into into HTML, and then you can render them in your browser, like I'm doing here. And speaking of these tools, obviously, we want to store our content in an open manner. And what better way to do this other than GitHub? As the most widely used open source platform, it was kind of the obvious choice, honestly. And it allows us to do all the remixing, redistributing, and revising via pull requests. I've already mentioned and put heavy emphasis on using Markdown for stuff including slides, and Reveal MD as the tool to convert from Markdown to HTML. Remember when I was mentioning lab setups and practical sessions, that we want students to have an environment that they shouldn't have to struggle with deploying and installing all the necessary packets? Well, Docker is very useful here, and we definitely leverage it. When we try to assess assignments and do all the grading, we use a lot of CI/CDs, mainly from GitLab, which we connect automatically with our learning platform at our university. We use Moodle, and then that's able to export grades as they are awarded automatically into Moodle and into the registers, so we don't have to mess with that at all. And finally, all of these are going to be done via scripts. We'll have scripts to automate publishing slides, publishing content, publishing lab work, publishing assignments, so that we teach more than we, let's say, fiddle with administrative tasks. So now I'm going to show you what the results of our work have been. We started from an operating systems class. Both of these are pretty low-level classes that we're teaching right now. And then we're in the middle of transitioning a software interface class, which teaches assembly and a bit of memory security, to the same Open Education Hub paradigm. So this is what things look like. This is what the finished product looks like for the operating systems class. You can see we have a separation between lectures and labs in this sidebar here. And the lectures are using the same type of slides that I was using, written in Markdown and rendered in HTML via Reveal MD. And when it comes to labs, it's just Markdown that's rendered using Dockersaurus. You can have multiple flavors of rendering. We just configure the layout of our website, and it's published in this form. Every time we integrate a pull request into our repository, which I'm going to show immediately, the website gets updated. So there's no discrepancy between what content we have upstream and what students see. If we make a change, if it passes our verifications and we merge the pull request, students see it immediately. And this is what a work in progress looks like. You see, we have a slightly different philosophy with this course. We're a bit more granular because this is a more introductory course, and basically we teach about memory, pointers, and then go into assembly and security. And you should actually, let me show you what structure, what the storage looks like. So this is what we call presentation. As I said, all this website is rendered automatically using Dockersaurus. Storage is achieved via GitHub. And we try to split our units, whether they are reading or tasks or quizzes or other types of drills, as granularly as possible, so that if someone wants to move a certain unit or take it and use it in their own teaching, they can do so very easily. They can just pick a task, let's say this one, as it is. It already has the statement here, the support code and the solution already available to the public. And this can be integrated as it is into any other teaching material with as little outside interference as we thought at this time. And the situation is similar to our operating systems repository. So we're mimicking the same structure and the same presentation across multiple courses in the hope of creating an array, a collection of courses, kind of like MOOCs are, if you're familiar with massively online courses, open courses, in which we aggregate various classes and deliver them in the same layout. Now, this being said, so the final product may look nice, or you may decide for yourselves actually, but there are some rather important challenges in doing so. The first one is that it's always kind of difficult to write content because you have to put yourself in the shoes of whomever it is you're teaching, namely the students, and try to see things from your perspective, which you might have forgotten along the way, or who knows. And then we want to have things very easily configurable. But for this, there will be a lot of duplicate things in order to keep tasks, for example, as granular as they are now. We're duplicating a lot of our infrastructure code, like make files and build files, because we cannot refer central configurations. Otherwise, you would not be able to plug in and out various tasks like this. Everything has to be self-contained. So this bites a little bit into the configuration, but it brings us ease of use. So there will be no silver bullet for this. This is kind of the point I'm trying to deliver. But you can always adapt because these materials are so easily reconfigurable and revisable. It's much easier to adapt on the flight as opposed to coming with a solution, what you think is a solution at some point, and then realizing a few years down the line that it was not the way to go, or not the way that you wanted it to be. I already mentioned when I talked about automation that we are trying to integrate our solutions with the infrastructure already existing at our university, in this case being Moodle, and our assignments are already sending grades and modifying the registers on Moodle automatically without us having to interfere with them. And this was actually one of the most important ones, that in order to have teachers being able to maintain these quality standards and maintain this level of interconnectivity between components, you're supposed to teach them to do what you're doing yourself. So it's essentially a type of teaching other teachers to be teachers further down the line. And this ties into the last point, that those teachers will have to maintain those repositories, because maybe you won't be there forever, and even if you will, you want to have other people also able to help in and not be a single point of failure. Therefore, in creating and curating the materials that I've presented you just earlier, some of the lessons that I found important were that first and foremost, I'd like to start with one change, one chapter, one topic that will serve as a model. So we will go on and on about that topic, try to make it as good as we can, and then everyone else that will make contributions will use that first contribution, or that piece of the first contributions anyway, as a starting point. For example, when creating these labs for the hardware-software interface, I was working with mostly second or third year students who had not been used to open source projects before, but our work has been quite fruitful so far, mainly because of the first two things that I'm going to talk about now. First is that we started from this first lab, and we spent quite a bit of time on it, on its structure, so that we made sure that everyone else in the team understood what was supposed to be done. And then after that, we went to the second point, which was to aggregate everything that we've struggled with, every point of contention that we had, and turn those into a rather lengthy to-do list. And the main thing about the to-do list was not necessarily how to structure the content. This was quite obvious. It was mostly how to use Git, because for someone who's new and for someone who wants to start developing content on their own, Git will be difficult at first. So this has to be factored in, and there's, in my opinion, no fast way to learn how to use Git and GitHub, because I'll get to that soon, other than just going into it, making mistakes, asking how to fix them, or looking for fixes yourself, and then implementing those fixes, and then remembering them. And GitHub tends to be difficult because that's where reviewing takes place. That's where our linters come into play. We also have automated checks for the quality of our content. It's nothing too fancy for now, rather than basic grammar, spell checking, and code linters to make sure it looks nice. And then everyone who's on this path of learning to do something new, in this case GitHub and Git and GitHub, but it can be anything, to be honest, needs lots of support. And to me, this has been one of the things that I learned to do, is provide support and provide help to the students that I was working with, so that in the end they managed to make high quality pull requests and deliver content in this shape that I showed you here. Yeah. So this is what my talk was about. Remember to join our Discord if you want to see what we're up to. It's right here. There we basically talk about what content we are going to develop in the future. We have channels dedicated to all of these courses and to new ones as we are creating them. And we want to create a community around open source teaching resources and open education in general. So even if you don't teach anything practically, if you're looking for a course that you may want to deliver without, not just deliver, but even follow or recommend to someone, give us a visit, give us a ping. We're more likely to help. Because we also know some resources ourselves, which they're not curated by us, but we enjoy them and we reference them a lot. Thank you. And now if you have any questions, go ahead. Oh, yes.
Thank you. So the presentation looked nice and all, but do you have any plans on how to handle pictures in the presentations? I mean, I'm not familiar with the rendering, but...
Oh, but we do. You include a picture. Oh, actually, I can show it to you right here. You include a picture the same way you would include an image in a Markdown file. And it just renders here, because RevealMD just converts a Markdown to HTML on a, let's say, line-by-line basis. So it converts a reference to a picture from Markdown into an image source, whatever, in HTML.
But the picture is still stored on GitHub? Or?
Yes, exactly. You need to store the
Okay,
picture
okay.
yourself, or you can reference it via a URL.
Okay.
Oh, okay, sure. Another thing that we like to do is create our own images. And for this, we use draw.io, which allows us to draw diagrams like this. What's special about them is that these are vector images. So first, we can zoom in on them however we want, and the quality won't break. And then they're editable, meaning that we can upload these images on draw.io, we can modify them, usually a little bit, and come up with new ones, which makes it very easy to create, let's say, things like this one, where we have multiple instances of the same thing. So these two processes were just copied and pasted, and it was a lot easier than just drawing each of them individually. And this is but one small example. When you have a few dozen of these, it adds up, and it saves quite a bit of time.
I mean, it won't overwhelm like a GitHub repository with a bunch of big pictures, essentially.
What sort of big pictures I'm meaning?
Yeah, like a lot of pictures. I mean, if you start like 5 slides of text, it's much less than 5 slides of pictures.
Oh, I see. Well, depending on the content of these pictures, so if they are, for example, satellite images, if you're teaching geography, then you won't need a vector image for this, because, I mean, you might have it in a vector format, but you won't need it to be editable. This is what I meant. So I think each each course should use its own version system. Maybe there are others that are more suitable to binary formats than GitHub, but as long as the content is accessible and reachable online without any, let's say, burdens, then it should be all right. I mean, nothing from what we're proposing is very strict. Our licenses are also open, which means that all we care about is for the content to be available both on and offline, and for it to be easily amendable. If you check these things, it's fine.
Okay, thanks.
Mm-hmm. If only I could find it. Yeah. Okay, so yeah, another thing that we like to do is to insert videos. The simplest way we found to do this was to concatenate multiple vector images, but they can also be regular images, doesn't really matter, into a GIF file. So this allows us to maintain each individual frame in an editable format, easily stored in a repository, while also making them into a video. This is done via some post-processing. So before the slides are rendered, the GIF file is created, but it's created from individual editable files. So we're also we're still maintaining our goal of having everything editable and reachable.
I have one question. Great presentation. I'm wondering if there are other universities or maybe other courses that also onboarded your repo.
Well, the University of Iceland is definitely also moving towards this. And then there are individual courses that are using our materials. For example, we have an operating systems internals course, which is very similarly structured to this. It's based on kernel development, and it's being used right now by some university in Prague. And we're definitely trying to internationalize our classes, such as this one. Yeah?
Thank you for the presentation. This is really interesting. What do you see as the biggest obstacles for educational institutions to start adopting this?
Oh, where do I start?
Broad question, sorry.
So, well, you know, the thing is, you need to start using this. You need to make the decision to make a change, and when you're trying to make a change, there will be obstacles. You know, the best way to not offend anyone is to not make any change. So I guess this will be the major obstacle in, let's say, overcoming all the negativity that is going to come from, you know, places around you and people saying, yeah, but why are you doing this? But then aren't our materials enough? Or aren't they good? Do you mean my stuff is bad? Why do you want my stuff to change? My courses to change? So yeah, I guess the initial head start is the most difficult one, convincing people that they should go down this path. That'll be the most difficult one. And I'm not sure if we have time for one more question. Maybe there aren't any more questions. I don't know. Are there? Can he? Can you? May he?
It's a really provocative question. So
Okay.
you have the content, right? The pictures and everything. You can create a metadata to say, you know, how this content can be treated and graded. Why do we need people to teach our kids? Can we just replace this with an AI and save a lot of money in the budget for education? Just replace everyone with AI.
Well, that would be cool if, let's say, the material teaching were done with AI. But then I think people also need some sort of guidance, mentoring, and role models.
Do they?
Don't you?
No.
Okay.
That's why I'm asking. You
well,
know,
I think
if you compare like the millions we spend for education, for people actually teaching people, which has questionable results, looking at the educational systems right now and the level of education in Europe especially,
Indeed.
do we think that the AI can? I'm not saying this is the way.
Yeah.
I'm just thinking we have everything in your system. How hard is to teach AI to teach people?
Well, I think this is definitely much harder than to teach AI to teach students or to teach, learners. Because if you're trying to teach people, so maybe I misunderstood your sentence. You asked about how to teach AI to.
Can we teach AI? We have all of the data, right?
Okay.
What stops us for getting a learning machine to get the data to create, their own course based on this, and use it instead of, a person, use it for AI to teach our students?
Well, in order to have AI do something, you need to be able to answer the question about what that something is. And I don't think we can find an answer for what teaching actually is. So we won't. I'm not able to define teaching now in let's say in an acceptable way by my standards, let alone by your standards, so that we can impose this definition and this view on teaching on AI. This is the beauty of having, let's say, human, not necessarily teaching, but let's say human mentorship and human guidance in things, because you don't have to have a unified view. You can just have everyone's individual view.
Okay, thank you.
I think we should be it. Thank you. I'm going to leave now.
Thank you for the presentation and for all the amazing questions. We'll now take a 2-3 minute break and we'll be back.
I just want to say really thank you. This is really interesting.
Thank you as well, yeah.
So you want more to this open source with that? Yes. I will we also teach operating system usage, like the basics of Linux and the advanced.
We also do that. I mean, he actually does that, the one in black. But I'm also involved in that course. We're trying to, we will be applying this model that I've discussed right now, that course starting from next year. We're taking things kind of one by one because honestly we don't have that much manpower to work with, so we have to schedule our courses and our transitions. Hello.
neki, jer ne mogu mahati. Okay, shall we start? Good afternoon, everyone, and welcome to a session related to future of open data. My name is Lat Moric, and right now I'm head of cybersecurity department at Algebra University. And today we will talk about open data and the future of open data, also the history of open data and the challenges and opportunities which exist related to open data. So, to begin with this presentation, we will do some overview of open data, say something about benefits of using open data, and I will say something about the presentation objective related to today's topic. So basically, what is meaning of open data? So open data is defined as the set of data which are available to everyone. And basically, in most cases, you can use this data in any way. There is no restrictions, and that is one of the problems which exist with open data, because the hackers also use open data and open source intelligence. So basically, they can use this data to design attack on some environment. And also, from other part, when we're talking about importance, so basically today there are a lot of opportunities related to open data, and different companies deal or governments deal differently with openly available data. But basically the promoters of open data are, in most cases, are government. And the main goal of the government is to, let's say, achieve better transparency to citizens and let's say earn some trust from the citizens. And basically we will talk about history of open data. We will talk about opportunities which exist, some use cases where the open data are used to improve some society. And also we will talk about some cybersecurity challenges. So when we're talking about history, so basically idea of open data start in middle 60s of last century. And again, the first country which introduced the open data was United States. But let's say until 19th, until let's say starting working with the internet, all this idea was not something which was majorly adopted. So basically you have some data, but you need to go physically to some location and work on that data. So before the internet, using open data wasn't that important. And some major milestones related to open data was in, let's say, 2009 or something like that, when the US government started with the gov.com website. And again, they start with like 100 data sets related to some government data. And today you can find like, let's say 300,000, almost 300,000 different data sets, which are made by the different government agencies, etc., and available for download to everyone. Also, following the United States, United Kingdom also start with the same page, and there is also in 2-3 years later the Open Government Partnership, which try to define some standards related to the open data. So one of the greatest challenges related to open data is, let's say, the quality of data, but also interoperability. And from the different sources, you can find the different data sets, and basically there is no defined standard in which way you need to publish this data. And basically that's, let's say, mostly hire your time, which you need to prepare data for something that you will do later, like visualization or using some machine learning to do some, to find some insight from the data. Okay, so basically, 4 years ago, the European Union also started with the Open Data Directive, and they built a platform for collecting data. And basically, in last 4 years, all the projects which need support from EU funding, the results need to be publicly available. So basically, if your research project is financed by, let's say, some European Union funds, your data and your findings need to be in open access. So this is the rule. It's not different even in Croatia. Croatian Scientific Trust also dictate if you use the funds from the trust, your data need to be publicly available. Okay? And of course, Croatia also followed these trends, and there is also data.gov.hr web page where you can find a lot of data sets related to the data data in Croatia, mostly collected with the government, some statistics data, etc. Again, we have some difficulties, and the one of the things that we talk a lot related to open data is freeness of the data. So basically, these data are free, but all these data are opportunity for the startups company, for other companies to build some products. And one of the example, I think that is true. To be honest, I didn't check that. I just know a few years ago that was happened, but I didn't check that. So for example, transportation company in city of Zagreb, in one point of time, create the API services which allow you to track location of the trains and buses, etc. Okay? And it was freely available. And what's happened later, they figure out that some companies make some application and earn some money from that data. And what they decide to shut down that API. So they are not know how to earn the money, but they don't want that someone else earn money from this data, which is opposite of this open data initiative, etc. But okay, probably that will be changed in the future. Okay, now we'll go with current state of the data. So basically, a lot of government institutions and basically government institutions are sharing public data, which I already explained. The main reason is transparency and basically to increasing the trust in the government. So also there is a lot of NGOs which are also working on the sharing data, but also working on the making standards for data quality, etc. So I mentioned already the data quality as one of the major issue related to open data. So basically, just imagine that you're using some type of open data. For example, using statistical data from Croatia because you are retail company and you want to open some stores, and you will probably need that data to figure out, okay, on which places you will put some stores. And just imagine that hacker in some way attempt that data. And you make decision on the data which are not accurate and build some shops where no one lives, but in data there is information that there are a lot of people living there. So it's a great challenge dealing with this open data, and because all this situation, and that situation is similar to a lot of different open projects, that security is not something which are, let's say, important for them because they want to spend the resources for collecting data and making data, and securing them is not much important, and because access to these data are basically free, they don't have enough resources to make good protection. Okay, so basically when we're talking about data, I already said that on United States you have about 300,000 data set, European Union have about 1 million data set, of course from the different nation, and all the data which are available on the Croatian government site are also available on the European Union Open Data website. Also, they create the platform for storing open data. Now they temporarily close it because they need to improve it because the amount of data was larger than they expected. And they also make some research and figure out that in next year, the value of open data will be around 200 billions of euros. So that is not amount of value of this data. It's an amount which company can earn using this data. So again, there is a lot of questions related to open data. So for example, all of you knows that European Union have own satellites, and all this data from these satellites are freely available. Okay, all these satellites are paid by our money. And data are not available only for European Union. There are like almost, I think, more than 10 companies in United States which use that data and have the product from that data which they're selling to European Union companies from the European Union data. Okay, they make the product and now they're selling. But personally, I'm not against that. So I'm supporting open data, open access to everything. And it's okay if they figure out the way how to earn the money from some data. It's great. So basically, earning money is not something which need to be concerned. Okay? So the main idea is that our lives are better because these applications exist. Okay? So I presume that all of you, when driving, using some navigation software or something. And why we have that navigation software? So, firstly, United States decide that they will freely allow access to GPS data. They can put some, I don't know, API keys or some codes or something to protect these signals, and they will only be able to use it. Okay, so they build a satellite, send it on the space. This is a large amount of money for all this system, and they decide, okay, it will be available to everyone. Okay, after that, the companies need to build maps which we can use. And okay, we are different ages, but of you with similar age like me knows that first 20 years we need to pay navigation softwares. Why? Because the companies build the maps of the roads, cities, etc., transferring these graphical or printed map to electronic one to support that. But in the last 10 years, maybe 15, I'm very bad with ago years something, we have a lot of free navigation application. And all these applications will not be able to produce without open data. Okay? So OpenStreet project, Google, etc. And on top of this application, we have a lot of different applications which use the same source of the data to make some improvement of these services. And for me, it's okay that they charge that, or we need to pay something for these extra services. But these free services are also great for us, and we will not be able to use them without open data which exists. Okay, so basically, benefits of open data are enhancing transparency and accountability. So today, in most countries, not all of them, but most, so for example, I don't think that there is any open data in North Korea or something like that, but the most countries have access to some government data, okay? So basically we can check the budget or of the country, how they spend the money, etc. And okay, I'm not sure in Croatia how we controlling the government. And okay, we have all this data, but no one use that for making decision. Especially we have elections few weeks ago or something, and no one check how they spend the money or something like that to making decision about voting. But the data are there, and we can use it, and we can use it for accountability of our politics. Also, the data can introduce the new entrepreneurs and the new companies which make the products from the data. So I may already mention you that there is some United States company which use this data from satellites, but there is also Croatian company which use the same data source and try to make some applications which will track some ecological incident on the sea or something like that related to satellite image. And the source of this image for them is free. Okay, so in most cases, most these services have some, let's say, basic services are free, like in open source software. Basic services are free, but if you need more resolution or something additional, you need to pay for that services. And of course, very important things when you're using this open data, in most cases, you can make commercial product and you don't need to pay some fee for that data. Okay, and also very important things, we are now living in the world of artificial intelligence. My own opinion that artificial intelligence doesn't exist, but I use that term because audience knows that terms, etc. But I knows, and I used to work in that industry, I know that machine learning exists, and it's very powerful. And basically, from year to year, it's more powerful because we have more powerful hardware, new algorithms, etc. And all this open data allow us to work with that and make some insight. Combine this open data with some own data and find some insights in that data. One example, which was like, I don't know, 20 years ago, from one of our colleagues, which was, I think, his PhD or something. He used the open source data related to the weather and tried to find some, using machine learning, tried to find some correlations between the weather and customers' behavior in the shops. Okay, so basically 20 years ago, he found out that in the shops, people are buying more during the rain. So basically, who collect the data about weather? No one. So we have agency for the weather or something which have that data, but basically company don't collect. They connect some transactional data in database, etc. And without access to this openly available data, you will not be able to find that find it out. So basically, this data allow us to go to data decision driving data decision making decisions based on data, etc. Okay, so one of the challenges are data quality. So we already say something about that, and especially issues related to intentionally changing data, but there is also situation where during collection of the data, we have some issues. So for example, right now in the audience is one of my colleagues which working with the weather data, etc. So when we have a lot of sensors in collecting some of this data, sometimes this data can have some problems or sensor have some problem. So when collecting data, we need to have some algorithms which check, not just store information which probably is not true. Because if we do that, we will have a problem with the data, and when we build some machine learning models based on data which are not accurate, you have this garbage in, garbage out, so your decision will not be good. Also, the issue is standardization. I also say something about that. So basically, there is no some defined standard or framework which say, okay, all open data need to be published in some specific form. Okay? And basically, the issue is how we can combine the data from the different sources. We need to spend a lot of time to combine them. Also, one of the greatest issues is the privacy and the ethic concern. So previously, we have a lot of situations where the companies publish some data and they use some forms of anonymization of the data. And one great example is Netflix, which have that issue like 7-8 years ago. So basically what they do, they publish the watching history of all Netflix customers, but remove all personal information. Okay, so there is no information about name, surname, something. And they publish that to the Kaggle web page, which is related to, let's say, data science challenging products, etc. And I think that the ML lab from MIT needs less than 1 week to connect 97% of these anonymized records to the real names. Okay, so how that is possible? Anyone have an idea? So basically, they use some other open data sources, and one of them was EMDB site where the people are rating the films. And from that database, they figure out, okay, someone rated this film, after that, this film, after that, this film. They check the Netflix database, okay, someone watched that film, after that, that film, after that. So basically, there is no confirmation that this matching the names to the data set is true, because they don't know, is that true? Or maybe someone in reverse order do something on some different site. But there is a big challenges. Also, some of the challenges can be related to allowing access to some personal data or publishing that data in the way that we think that they are anonymized, but using some statistics method, summarization or something, you can figure out or make some data related to some specific person. And we have a lot of this situation. And something which also happened is a situation where we accidentally leave some personal information in data set, etc. And we also have a lot of similar situation in the past. Of course, all these situation, if we be in some of these situations, there is some legal and regulatory consideration. So basically, right now we have GDPR in European Union. So basically, you can pay some penalty or fine for leaking of some data. Okay, now we will say something about trends. So basically, from year to year, we have more and more support from the different governments. And basically, without governments, we don't have open data. Basically, in most situations, open data is something which are supported by the government. Even if we use data from NGOs and some other organizations, they are in most cases paid by different governments. So even NGOs in most cases are supported by the government. And also something which exists last 10 years is the rise of open science and open research data. So basically idea that all, or not all, but the most of scientific work are paid by the government. So basically, if you're working on, I don't know, some institute or some faculty which are not private, okay, so when we're doing the research at Algebra, we don't receive the government money, okay? But if someone who work on the public universities, they are receiving salaries, etc., from the government. And when they do some research, so the main idea is that everything that they do need to be publicly available. And we have a lot of open access scientific journals, etc. But the problem is because you need to pay more if you want to publish something in open access. And if you receive some support, as I already said, you need to publish on these pages. Okay. Another one, we can use it in different sectors. We can use it in healthcare. So basically, we have a recent situation with pandemic. So there is a lot of data sets which help resolving this pandemic crisis related to infection, related to using vaccines, etc. Also, in transportation, so we have a lot of situations where we can use that in transportation to increase efficiency. Also environmental monitoring. So I already mentioned this watching the sea, but also there is one of the NGO which regularly check the forest in the world and from the satellite image and deal with this environmental situation. Okay, I need to speed up. I prepared too much slides and I like to talk about all of them. So basically, when we're talking about cybersecurity, so basically it's related to all this data. So it's related to the threats to the data when we're collecting the data, when we're storing data. So we need to use different techniques like encryption, like data masking to protect confidentiality and the integrity of the data. Also, in some cases, I think that can be very good practices, even if the data is openly available, that we need to have implement some access control. So basically that you need to make some authentication or something to be able to collect data. Okay. In the past, we have a lot of cybersecurity breaches. For example, in Los Angeles, some personal, in open data, there was some personal information. Also in UK, there was some publicly available data set from the health. It was like 6 years ago, and there was information which allow us to connect all this data to the real persons. And again, there is a consequences. So basically, they need to pay some penalties, etc. Okay, so basically what we need to do is to protect our data, to protect access control or implement regularly update the services, etc. Also, there is different frameworks which can be used. We have Open Data Charter, which sets some best practices and principles which can be used for collecting and storing the open data. And of course, what we need also to think about that technology is evolving all the time, and that's something which was, let's say, good security today, tomorrow will be probably not so good because technology evolving. And also, what we need to implement is some strategic recommendation for the stakeholders who need to make some decisions. So basically, we need to promote using the standards, especially for open data, that everything can be standards and even security or data quality, etc. And also creating some global platforms for storing the data. So basically, it will allow us to spend less on security. Okay, so basically, just to finish up, we talk about history, about state of open data today, and we say something about security. So, anyone have any questions? I spend all the time, but...
All right, thank you. Since we don't have a lot of time, I'll skip my provocative question. Okay, so I create and use really a lot of open data as part of OpenStreetMap project. I noticed something very dangerous. I want your opinion on that. So you said we have millions of data points and we produce more and more and more because someone said so, right? Because European Union said everything must be open. But I find majority of the data sets really useless, not to use any other bad word. And that requires a lot of automation and people to produce them, a lot of money to store them. And those data centers, they produce CO2, which is wrong for the environment. And we keep and going in that loop just for the aim of being open. So do we need as a society a way to see if the data is usable, and if usable, to store it, and it's, you know, crap, just to delete it? That's my question.
So basically, I'm not 100% sure about that, but let's say last 2 years, there is a lot of talk about data-based. This is the problem which you emphasize right now. And what is the major problem related to data-based? Something that you today think is useless, are you sure in 10 years will be useless also? So basically, if you think in that way, someone from 200 years ago can say, okay, why we're recording in the books the temperature of the day? Why we need that data? Because if you have more than 200, how you can use the data? You are not able to make any calculation after, I don't know, 10 years of data. You are not able on the paper do anything from that. And maybe they can say, okay, this is the waste, we will not collect that data. And today we have the computer systems which can very easily calculate that. So the main problem is how you can categorize something that is waste. Okay, from the today point of view and the tools and the algorithms that we have today, it is waste. But in the future, maybe some of this data will be helpful to resolve some problems. So this is only my opinion. Okay, anyone else?
Hi, thanks for your presentation. I was curious about one aspect that you had mentioned during your presentation, which was about this problem of lack of standardization of open data. And feel free to not take this question if it's a bit too legal for you. But I was curious to know if this open data directive, if you're familiar with it, provides any guidelines or framework for standardization of this open data in order to make it reusable within public bodies and organizations and within different governments in EU? And if not, is this problem being addressed in these new regulations, so say the Data Act, the Data Governance Act?
So as I know, there is no any technical specification how you need to store the data or how you need to protect data. There is some articles which say that data need to be stored in the way that anyone can use it. So basically, in most cases, they are stored in that way. But you need to spend a lot of time to convert that or the same data on the same platform can be stored in different way. So basically, what's the main problem when we saying about storing data? So if you have some data set from United States and Croatia, so they use the dot decimal notation and we use comma. So basically, I can't connect that data, I need to transform that. So if you need to build some global open data standards, we'll need to define all these things. Okay, it needs to be written in that way. It needs to be written, for example, times need to be in GMT or something like that. So it's not so easy.
Thank you.
Okay. Thank you very much. And I hope that you learned something about open data today.
I mean, I'm okay with everything. The way you see it better, that's okay. That's okay. Razvan. 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 Yes.
May I have your attention, please? May I have your attention? Please welcome to the stage Mr. Razvan.
Hi everyone. Let's fix the door. Cezarhin, Alexin. Okay. All the Romanian fellows are here. Okay, so I'm Razvan. I'm from Romania. I'm going to show you Unicraft, an open source technology, and the way we've been using it as a commercial side in a product that's called Craft Cloud as part of the startup we are part of. So this is kind of a blend between an open source technology and then a commercial venue. Let me start with the demo of things. So what I'm going to demo you, I'm going to demo running WordPress using MariaDB as a database. All of these based on a Docker and Docker images. And we're going to use Unicraft technology, a Unikernel technology for this, and we're going to deploy them on a cloud platform based on this technology that's going to be amazing and make things very, very easy and fast, which is Craft Cloud. So let me just start with this. What you see here is my setup. Most of you may know the typical Docker file. This is where all the information is being kept. So here I have, I'm importing the remote WordPress from Docker Hub. I'm installing Nginx to be able to serve it, and then there's the wrapper that I use. If you want, I can look at that. That will turn up the PHP SDF package manager, and then use Nginx on top of that. So what I'm going to do if I'm going to just check this out quickly on the remote end, there's nothing. So I'm going to do, I'm going to start the MariaDB server, and I'm going to start this instance of WordPress. I'm going to cheat a bit and just look ahead and start MariaDB like this. This is going to create an instance, a remote instance of the full MariaDB WordPress using 1 gig, and I'm going to start it, and it started. That's it. So currently, if I'm going to do it as well like this, I have the MariaDB instance. It's already running. If I'm going to inspect it really quick to see what's happening on the remote end, these are the log files that are being sent out by MariaDB. It's running on top of Unicraft. So there's no Linux kernel there. It's running by Unicraft, the custom kernel. Next, what I'm going to do is I'm going to also deploy. It's a longer line. Can you find it? Yeah, it's a longer one. This I'm going to deploy WordPress. Let me just clear this out. So what this does is -e. You may know from Docker. This creates environment variables, and what I'm going to do, I'm going to use the MariaDB WordPress I just installed. I'm going to database the user. I'm going to name my instance WordPress. I'm going to use the example name, also 1 gig of RAM, and then make it very good. I'm going to start it, and it's done. So what I just started is a full VM that's running as a virtual machine running Unicraft. I have a URL here, so I'm going to open it up. It's DAL0, so if you put a URL there, DAL0, that means DAL. So I should have been using Transio, a native location is from Frankfurt. I'm using one from Dallas, so it takes a bit of time to connect it there. So I'm going to just quickly install this. I'm going to call it, well, let's call this DORS PHP. Here. Sorry? Yeah, sure. This one? Isn't it large enough? You can see it? I can see it. Should I make the channel larger? And okay, let me do it. Is it better like this? Okay. I'm going to use Unicraft, then I'm using Unicraft, the big one, no one is here. Just to link my email address. And then confirming the password. And based on this, I'm going to now install WordPress. It's now installed. I can quickly log in. Unicraft, Unicraft. Okay. And this is here. So if I now go here, this is the full installment, it's remote accessible. We can access it, WordPress.all0.travel and you can see this installed over there. Just like that. And it's working, once again, using this technology, using fractional time, everything's running on the cloud, you're just going to benefit from it. This is one of the demos I want to show you. The other one, if we look here, I'm going to just check, let me turn on my slide. This was the WordPress. There's another one I mentioned, is Type. Type is an open source API gateway. It's using Redis behind the scenes. I know the story with Redis, but bear with me. And once again, going to use Unicraft and Kafka as a demo for this. Let's move here. So I have here Type. I need to check out the given branch a second. Okay. For Type, for those of you who are a bit familiar, I'm going to use Compose or Docker Compose. And what we have here is there's the Redis instance. I'm going to start, and then the Type instance. I'm going to use the remote HTTP port, and then connect to the Redis instance. So if I'm going to do this, similar to you know Docker Compose up. I'm doing something similar. Cloud Compose up. And what's now going to happen is it's now creating the Type image, it's deploying it, Type latest. It's using the network, thanks to Redis, it's deploying Redis. That's it. Starting with the instances, and this is it. So what you see here is a message from Type and from Redis, it's connected to it. It's now, if I look here, I'm going to have 4 instances. I have the previous WordPress and MariaDB instance, and I have the Type one over here. So now if I'm going to do like, I'm going to curl this. This is type.code. Type.redis.all0 from.cloud. From.code, is it shows up? Hello. It has a bit of a glitch. It provides me this. So this is actually clearly Redis behind the scenes, and it's something like that. So it's similar to what you would use with Docker, except it's running on the cloud, it's running canonical technology, and it's running really fast, really small, and you can see how kind of easy it is to go to that. We're going to take a look at some other demos right at the end. Let's get back into this. So we saw 2 demos of how we can use Unicode technology in the cloud. This is what's actually happening there. So what we're concerned about as the developers or DevOps or people that deal with technology, we want to deploy applications, we want to run applications. That's what software is about. And we want as little friction from that as possible. If I have an application that I want to run, be it a server, going to see some nice games here, databases, I just want to click some buttons and it works, and I need an endpoint, some sort of URL, and that's going to be. So I'm concerned about quickly building, packaging, pushing, unpacking, running the application as best I can, and releasing of all the work. Just let it work. Typically, because of that, because there's dependencies or other items, people are using containers or virtual machines for this. The default one is containers. If you're going to look into a user Kubernetes presentation, everything like that, everyone's about containers, serverless, after service, whatever. What you do is to be able, by using these, to run everywhere. You don't care about your platform. You can run on any sort of other platform, edge, cloud, whatever. Local dependencies, it gives you isolation. And there is 2 alternatives, VMs and containers, right? And people have been using like crazy up until, currently, not up until even now, using containers. VMs have some upside and some downside. The upside is they provide good isolation, they have good resource control, and can keep, I'm going to your VM and I'm going to run it mostly everywhere if I use a proper request technology. But it has lots of overhead, and it's a difficult one to create recipes for it. Recipe set. So you know what? There's background files, there are some items, but it's a bit tricky to do that. Whereas containers, these are kind of the gateway to heaven to answer the situation. You can make recipes by Docker files. You can store those recipes in registry on Docker Hub or GitHub Cloud Registry, GCR, Microsoft Registry, all those registries. You have tooling for it. You have Docker, you have Podman. They have good performance. They don't suffer from some items like virtual machines. However, they have isolation issues, and people are concerned about that. what if the Docker container escapes? What's happening to my system? That's one. And oftentimes, because of the difficulty of deployment, they are often provisioned inside virtual machines. If you're going to run Docker on Windows, or if you're going to run Docker on Mac OS, you're going to see some vulnerabilities already behind the scenes. So it's not a pure container technology as you have with namespacing and security on Linux. You have a virtual machine. Also, because of isolation concerns, if you deploy something on the cloud, it's often the case you start a VM, and inside that VM, you run a container. So you have a container inside the VM on top of your cloud technology. And what we're going to do is cut the middleman. Let's do one of those there. So what we want to do is we want to have good isolation, we want recipes, we want registries for the recipes, we want tooling, we want good performance, we want deployment on the cloud that's going to be fast, low cost, and scalable. Yeah, we want everything, right? So, and I think we are able to achieve that. So how do we do that? Well, we do that with Unicron. Good isolation, use VMs. Recipes, use what Docker has been doing in all the things. Use Docker files, use CLUC files, our own version. Use Compose to put the applications together. Registries, we use OCI image as any sort of Docker container, but pack the Unicron image inside the OCI and using tooling for that. Tooling with Craftkit, the companion one, we're going to talk about that. And we're going to use Unicron, our Unicron that's focused on what we call experience visualization to be able to get ultimate performance. And the deployment part is Cloud technology product buildable Cloud, and using a lot of different areas to ensure we're going to see scalability, scale to zero, fast boot times, death to cold boots, and many other things. What's happening now? What's the current state of things? Well, we have application support for a lot of items. Most languages are not supported. If you go on our platform, you're going to see that. Everything is there. Also, if you're going to be part of the hackathon on Saturday, you can use any language for application you want. Frameworks. Most popular frameworks on each language is there. I didn't have room in a part. There is Next.js, there is Velvet, there is Express.js, React.js. All most popular known frameworks are already out there. Right? So I didn't have room for that. Databases, most popular ones are there. There was a lot of discussion on Postgre. Postgre, yeah, sorry for that. It should also be here. Sorry for missing it. Web proxies, any other applications. And then because of the use of Docker technology, it's quite easy to add to our registry, to our catalog, those items. There are few URLs, you can find them here. If you visit GitHub, these are open source. You can look at the catalog of the application, the open source one, you can get the top examples, and try your best with it. You can register, get the token, and see how they work. How does it happen behind the scenes? What's let's say, the magic sauce? We use Docker because Docker is amazing technology, but no running with Docker. So we use Docker for building, Docker files, building all those items, but we run with Unicron. So build with Docker, run with Unicron, deploy on CloudCloud. And you deploy things on CloudCloud, and all of these items via the tool that we provide, that you've already been working extensively on, which is Unicron. So this is kind of the ecosystem that we use, which is heavily open source. What are the ingredients for it? So I'm not going to talk about Docker because Docker, I'm assuming you know, but Unicron. Unicron is something we've been developing for about 7 years. We are now working towards release 0.17. This is the latest one, 0.16. We are now making progress, and I'm keeping on Radu and Stefan at least to do the final review to have this out. We've just recently been part of our third year in Summer of Code. This is the, let's say, Unicron open source technology that's behind everything. This is an evolution of things. On March 2021, we joined GitHub. We didn't use GitHub so much by then. It was 200 stars. Now we are close to 2.53 stars. We have a healthy community on Discord, close to 1.8 users. The number of commits is kind of constant. What you can see is that the number of lines of code has decreased. This is because the project itself has matured, and now we are doing a lot of, let's say, optimizations and improvements, not so much feature additions. There are overrides and redesigns, and there, as anyone in a software company knows, there is always this trade-off of, do I want to reactivate things now, let's say 3 months, or do I just do a feature that the client requests? This is our evolution of start history. This is something that's happening. You can see some apps here. This is the first time we did a Reddit post. This was me requesting some people to do a Star Wars and university. That's why it's good to have a university connection. And this was actually, we did an official launch of Cloud 2 months ago, and this was in all social media, Reddit, Hacker News, and it got us this boost, but we are kind of healthily growing throughout the year. How is this an issue? Because the topic is mostly on Unicraft, and what we do and what's been a major step upwards is having Unicraft as a POSIX compatible kernel, meaning it provides the same layer as Unicraft. That's why we are able to use any sort of pre-built Docker compliant application out there and run it on top of Unicraft as it is, no changes required. So how this happens is we take your from this application itself, it makes a call, this call ends up in a libc call. This is typically what's happening on an Unicraft. Then what this does behind the scenes does a syscall which lands on usually on Linux. What we do is we trap this syscall in Unicraft. We have something that's called a system called Sheen layer. And this system called Sheen layer has its own redirection of the call to the internal implementation. Be it socket, be it file systems, memory management, what you will, any sort of syscall is going to be mapped here. Well, not every sort of syscall. Most syscalls that are required for most applications out there. There may be some fringe applications that don't work well with syscalls, but during the past, I would say 1 year or so, we managed to have a rather complete set of POSIX compatible syscalls to enable all applications to run. And then what happens is there are potentially support libraries such as the references that is used, LWIT, that does all of this behind the scenes. So what this does in the end is provide us the POSIX compatible kernel that we are able to pack into the application and reap all the benefits of the technology. All of this is enabled by Crafty. Crafty is our companion tool. Crafty is used for configuring, building, setting up, running, packaging, pushing, pulling, all the operations we do with Docker, with any sort of tooling, you know, with Crafty. It's using Golang, and it's fully open source. There's a report, you can use that. And it's basically integrating with Docker, with BuildKit for building, with Compose as the specification. It has integration to Kubernetes, Terraform, so it kind of has the glue that's required to interact with the kernel, with the platform, with Cloud, and then with some other tools that may have been built by the cloud community. And everything then, this is the commercial offering, the Cloud is the platform. We call it the millisecond platform, and it's the only kernel platform that we know of. And what it does is, apart from being, let's say, built up the technology, provides auto-scaling and scaling to zero. Makes the most scale to zero because those auto-scaling means you're going to very, very quickly adjust your loads, your number of VMs, kernel VMs based on your request. It's particularly useful for bursty workloads because it scales so fast. And we call it the platform that you don't pay for either. If you don't have any sort of workload on your application to run, you won't pay anything. So this is going to be what we think a drastic reduction to the cloud cost, apart from simplifying the entire cloud software stack. Let me demo Nginx on Cloud just to show you how the scale to zero feature is happening. So I'm going to show you here. Let me see if I have this in the history. I did also some recordings just to be on the safe side. Yeah, I don't have it here, just a sec. So I'm going to do, let me see where I stored the command. Yeah, I have it here. It's a rather longish one, and I don't want to mess it up. So what it does is it creates an instance, and this -0 argument, this means it's going to scale to zero. You're going to see about that soon. It's creating it a name Nginx, the subdomain is Nginx. I'm going to start it. It just started, that's it. It booted in 20 milliseconds. A full Nginx instance in 20 milliseconds. I'm not sure if it's pretty cool, but the other ones definitely for a millisecond platform. It boots really fast because it is our technology that I practice with them. We're actually looking this is the what's happening there. You see it's running, right? Now if I'm going to, I have to mean that is fine. Now if you're going to do a cross-cloud info to see the image, it says it's standing by. And this time, it's not using any resource. It's closed, right? And you see it booted in 21.56 milliseconds. Let me curl it. It got the request. Let's look at it again. It's also standing by. It's now 21.12 milliseconds, right? Because it shut down, and I made the request. It restarted. It served the request, and it was on. Total uptime was 3 seconds. So if I'm going to do now, info, that's how much it goes. Let's make a query again. Let's info it again. It's now 20.97 milliseconds. It's taking me back. Okay? It now has a total uptime of 4 seconds. I'm getting up, serving, and then shutting down. And it's doing nothing. So at this point, no resource is going to be used. So it's going to be for you as a client, no payment for this. I have a command here that's a bit longer. I don't have it here. Let me just copy it. So what this does is it does a curl, it does a query, it waits a bit, and then it queries it again just to show you how this feature works. So it was running, it's sleeping, and now it's standing by, right? If you look here, it ran, and then it was running. It says here running. I waited a bit, and then it went to bed again. Now it's 24.30 milliseconds. Boot time, so it's just this, another thing. So the start time, it was started 4 times. This is the 4th time it started. This is still to 0. Don't pay for idle. Shut it down, reboot it, because based on the methodology, you have those, it's what we call death proposals. You don't spend any time booting the thing. Okay. So this was the demo on using Nginx to scale to 0. And just as a reminder, I spoke about this. We're going to organize this weekend a Unicraft hackathon. It's going to happen here in Algebra University. You're more than welcome to join. We're going to have 2 days. 1 day of training and free, 1 day of you designing your own app for the cloud. So you're going to design a cloud application. We're going to deploy to the cloud platform. We're going to then provide it to the world as each one. We advise you to provide it as an open source project, as an open source application that's going to be part of your portfolio and also contribute to the open source community. Okay, so CLUC hacking, pizza, teamwork, mentally, everything that happen there. It's fun times. We have people here who have been part of those hackathons, so you can also ask around. This is the page of the hackathon. Join that. There's a login form there, and you can fill out because you need that login form because they can send you a token to be able to then access and deploy the platform. These are the resources you can use: Craft Cloud documentation, our website, our Unicraft server, our server. And as a reminder, and I need to just send it one more time of this slide. This is what we are going to do. We're going to use Unicraft Cloud. We're going to use VMs as the solution that provides you good performance, recipes, cloud deployment done right, no bloatware, vertical, both scale to 0, auto scale, using registries, using tooling and everything. And as the fun stuff, Cesar just showed me, so we have some fun applications. This is a Flappy Bird app. So you can see here, I hope it still works. Cesar, okay? This is the, I'm dead, okay. But this is an application, yeah, I'm better. This is an application that's running on Unicraft. It's Node, Cesar? It's Nginx, okay. And then another one, this is XGL. Yeah, weather, feather, .0, whatever. And you can use it, it's the first time, I just got half an hour ago the link. And click back to continue. Okay, let's see how it goes. So this is running on our Frankfurt servers. And yeah, I also have some sound here. I like the sound. Let me see if I'm able to run this. Okay, so this is running on Frankfurt. Oh, okay. Let me stop it. I'm not ready for this yet. Can I are the items. Thank you so much for being here. I'm open to any sort of questions you may have. Thanks.
Amazing stuff. First of all, really good. So first, really quick, do you support Erlang?
Sorry?
Erlang
Erlang,
language.
yeah, it's there.
It wasn't.
I just it wasn't. Yeah, sorry.
That's fine. I know. If you
if you go on guides, languages. Erlang here. I actually stop at some because I'm doing a lot of stuff to use Elixir. Likely, I'm not sure. Hopefully next week we're going to have it available as well. So I toyed around with that. It's a bit weird because of the virtual machine thingy, but we managed to get it working. Elixir is going to be very soon there as well.
And that kind of is then my next question. So with the Nginx, probably it's really cool, yeah, because Nginx is like itself is pretty small and it's compiled and everything, and it gives you static. But like when we, so
Java so for example, for Java, the start time for Java is 157 milliseconds, and let me give you the ugly one. The ugliest one so far wasn't Spring Boot; it was Rails. This was close to 600 milliseconds. I mean, for us, if it's past 50 milliseconds, is doom. Past 500 milliseconds, that's kind of, it's ancient history. So we need to work on that as well. There are some items we're looking for, but of course, we can only do so much because the application itself may be the bottleneck, right? So what we can do at the operating system level, we're going to do, so we are sure we can slash some of these items, but there's a healthy chunk that's part of the application. So for that, Andrea, there's a similar, let's say, company approach. She's going to talk about that. There's the potential item of doing pre-warming of these items, such you start them to a certain point, and then you simply load it to that point. I think Andrea may talk about that as an alternate solution that we are also looking into. Well, Bruno said, sorry for that,
and like really quick follow-up. So it means like, in principle, for every HTTP request, we just boot something up, serve the request,
shut it down.
Yeah.
With this possibility of, as Andrea is going to show, using this pre-warm item, we're going to start that. Even with this, I mean, at this point, it's miles ahead of what, I mean, I take some items, it actually takes close to 1 minute for some other items to boot. So not them to boot, but the entire thing, it's actually the entire flow. You start the button, then you go to Kubernetes to all those items until it actually get the endpoint. So it's not the application itself that's the bottleneck. It's mostly the intermediary infrastructure that gets that kills you.
Then the kind of question is, if I need to do some forensics on production, which I can do today, for example, I can SSH onto my pod in Kubernetes, stuff like that, and then run some diagnostics inside.
So you're talking about observability?
Not in the sense of collecting metrics and statistics, but more like, can I enter production and run some tracing code and collect some data?
The short answer is not yet. The long answer is there's a very, very soon to appear facility to allow you to get to what we call a debug console. You're going to have a debug console on each VM, and you're going to connect to it. So it's one of the prime features from our clients to be able to do tracing, and you're going to see threads, processes, all those items there, what's happening, file system,
and I can,
resource consumption, whatever.
Beans in, so to say, and I can look around, play
investigate,
with it. It's not like a snapshot that I just read only.
Get info from memory, from the disk, whatever that's required. It's as you would use some sort of, let's say, debugger inside the remote application.
Can I do PS inside that?
Yes or no, because the multi-app support is not yet there. Sorry,
Okay. Fair. I'll come back after.
We can talk a bit more. For sure. Yeah. Thank you for that. There's no more time, so we're going to talk on during the break or anything for anyone. Thank you. Bye.
And we'll have Q&A at the end. Okay. Your attention, please. Please welcome Stefan to the stage. And
Hi, everyone. I think we can wait like 1 more minute because he said he was gonna go outside and let people know that we're starting. Your colleague said that he will go outside and let people know that we're starting. So, 1 more. Yeah. Okay. Okay. Perfect. Yeah. Okay. Thank you. Hi, everyone. I'm Stefan, and we're gonna talk a bit about memory security in unikernels. It's gonna be pretty tied up to the last presentations that we had. So, yeah, let's just get into it. In 2018, a lot of you probably know this graph. The security team from Android said that they did an analysis of the memory, of the vulnerabilities that they received that year, and they realized that about 90% of them were caused by some sort of memory violation. Most of them were out-of-bounds access or use after free, about 70% of those 90%. A big cause of the big number of memory violations is the software bloat. And in 2017, there was a study published that, in short, said that about 13% of the library functions that are available to an applications are actually used, and about 21% of the instructions that are available are ever executed. So almost 80% of the instructions are useless, they're never even executed by an application. This means we have very big software, hard to maintain, easy to introduce bugs and vulnerabilities and stuff like that. A solution to that is to use unikernels. What are unikernels? As you saw, very small single address space operating system that only build the required components that are needed for an application to run. Basically, you have the usual virtual machine here that has a full operating system and multiple applications inside. Then you can have a container that runs an application on top of a kernel. But with the containers, you lose some of that isolation that a virtual machine provides. So you can just combine the two and have very small virtual machines that have a let's say, minimal kernel in there that use only an application. That way you have full isolation, but you also have the small footprint of a container. Let's say you have a web server that runs on top of a full kernel. You only use that small part of the full stack. Let's say you can just take those parts, pack them together in a unikernel, and then just run that with a minimal size. The unikernel project we're focusing today is Unicraft. Again, the same project you saw in the last presentation, a unikernel software development kit that is highly configurable. It uses the Linux kconfig style. You know the menu. You can, let's say, you want a file system, you can select the file system. You want, I don't know, environment variable, you can select support for that or no. This leads to very small application images. So a virtual machine that runs Nginx, let's say, can have, if optimized, about 800 kilobytes. That's, again, a full virtual machine image. So it's not just the application, it's a virtual machine of less than 1 megabyte. So again, smaller footprint means less memory vulnerabilities and everything else. Unicraft implements a lot of security features already, like undefined behavior sanitizer, true RNG, and so on. Another memory security feature that we looked at was memory tagging extension. It was introduced in 2021 by ARM with the V9 compliant CPUs, and it implements lock key memory access scheme to the hardware memory. Basically, it tags all the addresses in the memory with some tags, and then assigns the tag to a pointer. If when you do the access, the two pointers match, then you have a valid memory access. If the pointer are not matching, then that's a memory violation, and it can fire a trap. The MT is already supported in big projects like Linux, glibc, Android, Chrome, and so on. And we also support some sort of basic MT in Unicraft in the internal allocator, but the problem is that the allocator has a page size granularity, which means it can only tag one page with the same tag at a time. So if you have one page and you have two buffers, let's say on the same page, then the MT becomes useless because you can just jump from one buffer to another with an out of bounds because they use the same tag. So to solve this, we decided to implement MT in an allocator with higher granularity, and we chose the muscle allocator because muscle is the libc that we are using in Unicraft. So we want to tag basically every single allocation, no matter how small it is. If you want to allocate, I don't know, a buffer of 16 bytes, we want those 16 bytes to be tagged with a unique tag, so you can do any out of bounds or use after free or anything else. There are some potential issues with this implementation, and basically the fact that MT is very, very restrictive, and you cannot do any kind of out of bounds memory access. You will run into some by design, let's say out of bounds accesses that applications do that will no longer be viable. We ran into one of these examples with Python. Python uses an internal allocator for allocating objects, of course, and then it needs to free those objects in the memory garbage and so on. And what the allocator does is it allocates memory pages, and it places the buffers somewhere inside those pages. And when you do a free, you need to check if that buffer was allocated by a Python allocator or by another allocator. So you want to go basically to jump from the buffer to the beginning of the page and check some stuff there, some metadata there. If the buffer was not allocated by Python, then the beginning of that page will have a different tag. Basically, what Python does here, it's an out-of-bounds access. It jumps from a random buffer to the beginning of the page. And if the tags differ, then you will get a fault here. So basically, you cannot use this with an extension like MTE, which does not allow out-of-bounds access. We analyzed the results of memory tagging first using, let's say, calculating the memory overhead. So we need some memory to store the tags. Every tag has 4 bits, and you cannot tag less than 16 bytes of memory. So the granule of the tag is 16 bytes, which means we are using 4 bits per 16 bytes. It's not that much. It's about 3% of memory overhead. This is constant, so you cannot improve this in any way. Basically, when you enable MT support in the CPU, 3% of your memory will be used to store those tags. A bit more interesting to analyze is the CPU overhead, because the CPU will need first to tag the memory, so every memory it allocates, it will need to be tagged. But not only that, the bigger overhead will come from checking the tag on every memory access. Every single memory access you do will need to check that tag. This is done in hardware, so it should be pretty fast. We did not yet manage to get our hands on a hardware MT, let's say board or anything else from ARM, so we did the testing on an emulated environment. and that's not working fine. So on an emulating system, the overhead was up to like 400% on very memory intensive applications. But some other people who last year did an analysis of MT on some hardware supported systems realized that from that graph is the small white bars that we're interested in, that the actual overhead of hardware-assisted memory tagging is less than 1%. So we can say it's close to zero. Next, we're going to submit the patch for MT to muscle, and we want to do some more in-depth analysis on some hardware-assisted platforms, not just emulated metrics, because those are not up to reality. Now I'm going to show you a bit how this works in real life. We're going to use, again, Unicraft, so what you saw in the last presentation, but we're going to use everything locally. I have an Nginx image built here that we're going to run using QEMU with MT enabled. MT is also supported in muscle here. So if I just run this, sorry. This is going to start a Unicraft server. We can connect to it from the browser, let's say. And it started an Nginx image. This is working with MT under the hood. You can't really see it here because there's no memory violation done, but I'll show you that later. We can also try something else so we can see some metrics in real life. Let's go to Redis. We have, again, a simple script that just has the QEMU command. If you run this will start a Redis instance. We can then use, let's say, Redis benchmark to interact with it. And this will ping the unikernel and do some stats. Again, this is all on emulated systems, so the stats are not that good. There's some delay happening there, but it's working. Something a bit more interesting is what happens when you do have a memory violation. So here I have a very small main.c file that basically does a malloc of 64 bytes. It prints the pointer so we can see that it's tagged. It prints a message, and then it does an out-of-bounds X. This is something that would usually work in C because there is no bounds checking. This will write somewhere in the memory. It can overwrite some important data, or it can do other stuff. And then we print a message. This should not be printed. We should get a trap here. If we run this, so I've already built this. It's let's look a bit at the size. So this is the kernel image I'm going to run. It has 1.7 megabytes, and it's basically this little application built on top of Unicraft. Now if I run this, it's going to be machine word since, again, it's emulated. We're going to enable the MT support. Just add a CPU with max capabilities. We don't want any graphic, and then we just give the kernel image. I messed up. There we go. This gives us an error. Let me zoom out a bit. So what happened was the Unicraft banner. So here, after this, we reached the main function. This printed our pointer. You can see that the pointer has a tag in the first byte. This is where the tag is stored in case of the pointer. Here is 3. If I run this again, it will be a different tag. So now it's D. It has the byte stored there. Then the first message got printed, and then we received a trap. We can diagnose this trap. So if you take the ESR register and we enter it in let's go here to the ARM dev page. We can see that ESR says that we got the synchronous tag check fault because again we did an out of bounds memory access. Here we got out of the memory that we tagged for the P pointer. So that's about it on my side. Thank you. If you have any questions, I'm happy to answer them.
For the presentation, I have a question. Is there a way to debug the faulty line, or how would we will
Yeah,
if we have the line P65 equal to 0?
Yeah, so basically this is architecture dependent. If you get a trap like this, you will have the instruction pointer saved here. So you can just look at this register, you have the instruction pointer here, then go to your kernel image and see where that instruction pointer is coming from.
Okay, and the second question, do we have to make some modification of this implementation to adapt it to newer version of Unicraft? Because I saw it.
Yeah, it's running an older version. No, basically I didn't do any changes to Unicraft. All the changes are done for Muscle. It's the latest Muscle version. Anything should work. So basically the Unicraft, it's exactly the same as it was. I didn't change anything there.
Okay, thank you.
Thank you.
So I guess the architecture allows you to turn the memory tagging feature on and off, does it?
Sorry, can you?
The architecture allows you to turn the memory tagging feature on and off, doesn't it?
Yeah, exactly.
Okay,
Yeah,
so have you tried doing this to measure what sort of performance impact it has? Because if you're accessing an array multiple times, doing array of index I multiple times, I guess it might add up or not. So what sort of temporal overhead are we talking about?
Yeah, so you're talking about memory tagging on and versus off.
Yeah.
Yeah. So I didn't. Again, I don't have a hardware that supports MT yet. These guys basically did that.
All right.
And from this graph is the white line. So the first line is that basically don't even show up. Is that just the percentage? That's memory tagging on versus off. So it's basically less than 1%. Is about 2.4 was the biggest overhead. And
okay, yeah, fair enough. Thanks.
Yeah.
Any more questions? No? Okay. Thank you, everyone.
Thank you.
Is everyone seated? Okay, please welcome Ivo to the stage and he will begin.
Hi. Anyone here who doesn't understand Croatian? Right? So I need to speak in English, right? Okay. Just checking. I ask. No, it's not a problem. No, it's not a problem. I could try to do it in German, that it would be awful. So that's fine. Even more awful. Even more awful. Okay. Galerija, nisam vas uspio uvjeriti. Alo? Nisam, ja. Ovdje ima više pive. Ništa. Ajmo, imenjak, Bog. Okay. I see this is a full house in a bar, not in a... so my name is Ivo. I will have a presentation now about a legacy. I would prefer some younger people, because younger people are actually the target audience for this talk. But yeah, let's see. So I'm a founder and a partner of agency or web agency called NetGen in Croatia. There's roughly around 50 people. We also have the same branded partner agency in Switzerland, in Zurich. We work across Europe on various web projects. I have like 20 plus years of experience in whatever. I started with Pascal and Perl and then VB script and then I don't know what. At some point we got to PHP and Symfony, and then I basically stopped developing because I need to do everything else because I'm running the company. We also organized the summer camp. Summer camp is a conference in basically the point is to meet people at the Croatian coast every year. So it's an event this year in Opatija. I think I have a video, but maybe it will not work. See, maybe it will work. So this is how it looks. It's 3 days. It's web related, so in some way it has a lot to do with open source, because we have, for example, PHP track, JavaScript track, Symfony track, and then also UX track, business track, and the last day it's a conference day. So you can ask me later about this when you have the chance. Okay, let's go further. So why this topic about legacy code? So I was once a developer, and now I'm working with developers. We have, like 30 developers in the company. So I'm working with them every day on daily basis. We do a lot of projects, and I always kind of come to this kind of frustration when developers are dealing with legacy code. This is like on a daily basis, especially when you get younger or more juniors, less experienced developers, and they of course need to do work, or they need to maintain some older code which predates them. So that's what I kind of wanted to help, or at least give them my side of the story. So before we dig into this, I will give you a story, and maybe you will recognize maybe your experience or someone else's experience about this story of Zed. So this is Zed. So he's just graduated. He wants to be a developer. He wants to work in, of course, new technology. He doesn't want to work in PHP or COBOL or whatever. He wants to work with blockchain, for example. So yeah, he has some experience, but nothing much. Then he searches for a company. Of course, he wants to join the company which works with these cool new technologies. He avoids companies that use old technologies, like COBOL. And then, of course, after 1 month, he got a task to do something on an existing code base, and he's frustrated, of course. So he's not very happy. So he got the first project is, after all the frustration, let's rewrite this old shit, and let's do this new kind of, using new technologies, create a new project or a new product. So, oh, actually, this was the first project, sorry. He got the old code base. It took a lot of time. There was no documentation. The senior left. Every few minutes, Zed had a what the fuck moment. The what the fuck moments are very important because that's a measure of how good your code is. I will talk about this later. So, whose code is this? That was, he's like, who is this jerk who wrote this code, right? He couldn't grasp on it. So finally the company at some point agreed to start from scratch. So they just went with full rewrite because it was just too much stuck, right? So, and then they just said, oh, we will use the new technologies, no longer blockchain, but AI, of course. AI is now the new technology. And let's do this, by the book. We will have enough time, whatever. We have a team. And then they work for a year or 2 or 3. Rewrites are not usually something you can do very fast. It takes a lot of time. And then, yeah, we are close to the launch. Everything looks great. Everything looks peachy. Some still rough edges, quick fixes. Then the business, of course, requires some things that you need to compromise because they want to add it in the last minute. You finally went live. And then you learn the first thing that you need to learn as a developer or as an engineer. Nothing survives the first contact with the real user. You can test as much as you can. You can, create the best user experience with the best user experience consultants or whatever, but there will be problems because you cannot cover all the edge cases, all the things that users can invent, or they use your software in some weird way. So, of course, there are some bugs and edge cases. And then, of course, the user wants new features, so the backlog grows. And then, of course, the business wants to monetize, earn money on top of that. Business as usual. So after a few hundreds of features added, it's a mess again. The technology also progresses. AI is no longer the newest, coolest thing. There will be something else around the corner. Compromises. And then what happens is our Z, I can't remember when I wrote some meaningful code. He left and became a security guard. And the context is lost because there was a lot of context in his head. He went away. The new project has the same problems as the old project. That's what usually happens. And then we have Fabienne. She's also a graduate. She was hired by the company. She got a task to add a new feature to this project. All the same shit. It's just a cycle. So, and then she shouts, whose code is this? Zed's. Who's Zed? Not in my story. In my stories, he's just gone. But good you know some references. When I talk this talk to some younger audience, they actually don't know this movie. And that's super funny. I mean, it's one of the greatest movies in history, and they don't know it. It's legacy, exactly. So I need to create a new story of that, which will be a bit newer. So what is legacy code? When I was, everybody's complaining, this is legacy, this is shit, this is bad, this is legacy, blah, blah, blah. Then I Googled, what are the, how do you say what is legacy code? How do you define it? So anyone here dares to define what is legacy code? Okay, that's I would say the most average or the most let's say frequent explanation if you Google it, right? So I would say a bit more broader would be this. So it's hard to change. And why is it hard to change? Because the context is lost, the technology advanced, there is no more people around, and et cetera, et cetera. I would say that's, for me, when I try to speak with especially younger developers, I try to twist this. Why? I will tell you why. So legacy code is whatever generates value. I mean, that's a very hard thing to say, but it's important. So my claim is that legacy code is any code working in production. That's legacy code. As soon as you put it in production, so this is the first day, first live day, right? It's beautiful. It has no, you know, like problems. Everyone is great, loves the code, etc. But through time, it rots. The thing is that this will become legacy eventually. So you need to treat it as legacy because it's not the same how fast it will get to that rotten point. So you want to try to keep it not rotten for as much as you can. What comes from that is that whatever raises the technical debt, that's legacy code. Legacy code, the only thing that is not the legacy code is the code that you write on your own computer, on a test server, in a developer branch, which is not on production. That's not legacy code. Why? Because you don't need to maintain it. So as soon as you need to maintain it, it will rot, the technical debt will rise. So you need to treat it as legacy code. It's the same. If you have the newest Rust, Go, what's the newest technology languages, I don't know, or if you have COBOL, or PHP, or Pascal, or VB script somewhere on production, it needs to be maintained if it generates value for the business. That's the important thing. So, very important and related question, what is technical debt? And that's very hard to answer. That's very hard to answer, but I will show it like this. So, technical debt will rise over time. Doesn't matter what you do, it will rise. Because there are some intrinsic and external reasons why it will rise. Plus, whatever you add to it, it will rise even more. And if you add too fast, it will rise even faster. So if you add features, and if you don't maintain those, don't kind of, let's say, take care of it, the technical debt will grow. And you will pay it at some point. What does it mean pay? You either pay it by maintaining it or maintaining it. If you don't maintain it, you will pay it at some point because you will need to do a rewrite, because you will get stuck. And that happens a lot. You get stuck because you cannot upgrade it, you cannot maintain it, there are no people that know anything about this, and then you need to rewrite. Rewrites are expensive, like really expensive. You think, oh, this is just few things that we will replace with some new things. No, it's expensive. And the problem is that business will always prioritize new features instead of maintenance and controlling technical debt. That's like, because they don't understand things. They just want new things, new things, new things. They don't understand, oh, we need to garden it. Internal and external reasons. Internal, people go away. That's raising technical debt. If a senior leaves, that's raising technical debt. If, for example, the new version, major version of your underlying framework got released, it raises your technical debt. Why? Because eventually that version that you have will not be maintained anymore. There will be no upgrades, no security fixes, nothing, right? So you need to upgrade, and that requires effort, to be in the sync with the whatever modules, frameworks, functions, features, or external libraries you have. You need to be in sync with them. So actually, this is in reality how it looks like. You add features, but then at some point you need to consolidate. You need to maybe upgrade here, whatever. Some new people come and then they need to learn the system, etc., etc. But it's never zero. It's never zero. It cannot be zero. It always have something you can do with the code. Of course, how the technical debt disappears. If you can delete the code or not use that software at all. That's the only moment where you can annulate or completely have a technical debt fail to zero if you don't use that code. And you say, okay, this is, there is no value in this software anymore, we scrap it, we don't use it. Who is the best in doing that? You know Google? You know how many things they scrapped? It's almost 300 services or products they scrapped. Why? One of the reasons that they reduce technical debt. That's one of the. Why would you need to maintain this thing if it's not, if there is no future, there are no users, whatever. So what I tell to, or what I try to correct with the developers is, you know, when a developer says, my job is to write code, right? Just write code. In reality, writing code is roughly 15 to 10% of the time of a developer. What he needs to do is read the code, some existing code, older code, educates himself, of course. He needs to document what he does. He needs to remove unused code. He needs to upgrade. He needs to refactor. He needs to write tests, automate anything, tasks. He needs to mentor other people or other developers. So there's a lot of work he needs to do, not just writing code. Otherwise, technical debt will rise. He needs to have enough time to control the technical debt. And which actually means doing everything that, not just write code. You need to actually always think about how can I solve a problem without writing new code. Imagine this garden. So this is obviously a beautiful garden. You know for sure that this garden, that the gardener visits daily. You can see it because it's perfect. Imagine that for 6 months, the gardener doesn't enter this garden. Will it look like this? No way. It will be a jungle, basically. So, and then, of course, the most famous legacy is bad code. Every code is legacy, is bad code. Why? Because I don't understand it. Of course you don't understand it, for many reasons. It has a perception that it's hard to maintain, it's not cool, it's on older technology, old frameworks, old languages, etc., etc. And then it's let's say, self-enforced cycle, because they don't like it, they will not maintain it, it will get even worse. But don't blame, you know, if you say legacy code is bad code, which means that the previous developer did a lousy job, that he is a bad developer. And you can always say, okay, you know, like my predecessor was a bad developer, but you don't know. You don't know the context. The code was modified, changed, and adapted, and glued, and neglected, and it somehow survived all that, and it's working. That's the most beautiful thing about a legacy code. Legacy code works in production, provides value. You can write the most beautiful, shiniest code, but it has zero value if it's not in production. As soon as it gets to production, it's legacy code, because you need to maintain it. And this is the kind of, that's why I'm talking about, this is a philosophical talk. It's about, you need to try to think a bit different about the coding and maintaining. And this is I want to explain. You know, best intentions. every code is written with best intentions, right? But the problem is that, life, business, deadlines, whatever, compromises. And then there is one more thing when the developers like to say, I'm just here to build it. You are done. Your work is done. Well, actually, when you do some software, the implementing is actually let's say, the smaller time in a life cycle of a code. Of course, there are some cases when you write code and you need it only for a month. There are some cases like that, of course. But let's say on average, you write code for a year, it will be used for 5, 10 years, who knows? There is some code still running for 50 years, I presume, in reality. It's easy to just write some code and then I'm gone to some other green code, right? The cost of ownership is much higher in maintenance and not in writing. That's also usual. My code is perfect. I write the most beautiful code. Every other code is, not very good. But of course, we have this. We are humans. We are, of course, not very objective. We say this, but it's good to have. It's good to have the practice of, using a lot of commits and good practices and working with Git or any other source control, is because there is this thing called Git blame. I don't know if you know Git or any other source control, but there is a way that you can quickly find who fucked up. And it's really good that sometimes it's you. And you don't remember that you wrote this thing, and then, oh, this is me 1.5 years ago. I did this shit, right? So this is good for just kind of keeping the ego down. No code is, of course, perfect. It will be close to perfect if it's maintained. The only good measurement of code quality is not what you think in terms of, oh, my code is beautiful, etc. This is actually, after 5 years, when someone else opens your code, how many what the fucks per minute will be said. That's the best code quality measurement. Because, there is some other person, other mind thinking about in some other ways. If you didn't do the job right, there will be a lot of what the fucks. And then, of course, maybe the most important misconception, yes, of course it's annoying. Because you try to figure out what the person that wrote the code, even if it's you 2 years ago or whatever, someone else, was, thinking, right? So it's annoying, but I try to say, no, maybe it's a challenge. It's like a quiz. It's like a quest. It's like whatever. Do not judge because you don't know the context. One of my colleagues, he calls this code archaeology. Like digging into some old code. Wow, that's fun. Let's see what skeletons we can see or find. There's a good thing, which is called Boy Scout rule. I don't know how much of you know this rule, but there's a rule. If you open a file with a code, even if it's 10 years old, you need to make it better before you save it. Don't just open it and say, oh, it's shitty code, I don't understand. No, fix it. In that way, you kind of improve the code. Otherwise, it's just, bitching around, Try to do something about it. So always leave the code better than found. And then when the technical debt goes, Everest level, and then someone says, yeah, there is no other option. Let's just do the full rewrite. It always sounds like, it's not a big deal, We have better tools, we have better technology, we have better programming language, we have object-oriented, solid, functional, I don't know what, things, because the old code didn't have it. We will do it quicker. No, you won't. It will take a lot of time. I know from many, many, many examples. I can give you, for example, don't know exactly, Magento 1 to Magento 2. I think it took 9 years or something like that. So it feels like, oh, it's just a quick, we have the tools, we will do it. We have the knowledge. No, it's a lot of work, because in the first version, you accumulate a lot of features. You take it for granted. Usually, it's better to maintain, or from a cost perspective, it's better to maintain a code, not to do a full rewrite every 5 or 10 years. Because it's not about code, it's not about technology, it's about people. So if you have the same people doing the same old thing again, the result will be the same. It's about the culture, not about the technology. Garbage in, garbage out. So, any working or code in production, which we define as legacy, deserves attention. So, what can you do? You can do add tests, automate deployments, upgrade, remove dead code, refactor, making it easy to change, document. A lot of stuff can be done on the existing code. This is what happens. Kind of documentation, but. So, as a business, we need to incentivize maintenance, teaching developers, reward them. Maybe use ChatGPT to generate the documentation. I need a ChatGPT reference, at least one. Find some challenges, use some. There are some patterns around how to do. There are a lot of tools that you can help you with doing this. A lot of stuff. I will not go into that, which can help you maintain the code. Also, there is this thing, practice of why. When you start and then you see something and you question, why is this done? And then usually the first answer to the first why is actually not the cause or the root thing. So you need to go deeper to find why was this implemented? What was the reason? And this is where we come to also a very good thing. So when you document, usually if you have a function name saying, I don't know, summarize two numbers, sum two numbers, and then in the comment above you say this function sums two numbers. That's not useful. Document the why. So in the comment, for any future developer in 5 years' time, it will be way more valuable to actually write, why did you write this code, not just repeat the function name. That's useless. Right? What ifs, what happens if this developer, bus effect, so he gets hit by a bus, but maybe he leaves, maybe he wants to become a security guard or something. What if, what happens? So, you can do a lot of ifs, try to remove stuff, the ChatGPT, of course. To the businesses, because they make decisions. The best way about talking about having more time for maintenance of code is to communicate about risk. So tell them, if we don't do this, then this will happen, because a lot of bad shit can happen if you don't maintain the code. For example, security fixes or something like that. The bigger the technical debt, the harder it will be to respond to business changes. That's the usual one. So, a couple of last slides. So, do not judge. It's easy to judge the developers before you. Don't be so frustrated. Don't be like Zed. You will never be a complete software engineer if you don't regularly maintain a code. That's my claim. You will probably have a bigger impact of your business if you maintain the code, and instead of just trying to write some new code, it will maybe become a new project. So maintain the old code. It will have a bigger impact. Appreciate working code, and that's my thing. Right on time, right? Any time for at least one question? Okay.
Or I can just use this. So thanks for talk, by the way. a question. Like, it's easy to say that you can do something about it, but most often you can't. You've got the product versus development fight going on forever and since forever. And somebody's always going to want a new feature, and you're going to try to explain, but this is building technical debt. And they're going to be like, oh yeah, but premature optimization leads to too late to the market. And how do you sell the story of we're going to maintain our code?
It's hard. I'm not saying it's easy. I'm not saying. I'm just trying to kind of give you a bit more weapons to developers and engineers and tech leads to go to business and argument this, to give them a bit more, let's say, ammunition to fight for it. And it's actually better for the business. They don't know it, they will never understand it, but you need to at least try. But of course it's hard. You know, if the business doesn't understand it, it will just always say, no, don't waste time on that. We need to have this feature. You need to hide maybe. You need to say, oh, we need 20% more time, and actually.
Yeah, so what you're trying to say is basically instead of asking for 3 weeks, you're going to ask for 4 weeks because you know you're going to have to fix something.
That's
right?
one way of doing it. I know it's not a great way to lie, but yeah.
Thanks a lot.
Yeah. Yeah. Do you also have some? Yeah. I mean, there are some companies that understand it, and they have, especially product companies, because we are in a project business. So projects are a bit tougher because they are time limited, budget limited, etc. When you have when you are a vendor as a software vendor and you develop something which, 5, 10, 15, 20 years, and then it might be a bit easier because it's actually, you need to make sure that the software runs, because your business directly depends on it. There are some companies that, for example, say there is always 20% of time for maintenance, for upgrading, back fixing, security fixes, refactoring, etc., etc. So there are some companies that have this, but of course not all. Thank you.
Unfortunately, we don't have much time for more questions, so thank you, everyone.